with us two members of the Committee of Experimental Method and Instrumentation, Alessio Radiz and also Rui Ferreira. So, Kamal, when you want, you can call the first author and we can start the session.
Okay, thank you, Jose, for the introduction. Thank you. I would like to welcome all the attendees of this session, or the colleagues who will present, who will make presentations. So this session is actually a session that merges scientific and engineering presentations from actually three committees. So the committee of IAHR on fluvial hydraulics, which is very well known throughout the organization of the International Conference River Flow. The committee of IAHR working on experimental methods and instrumentation. So the chair of this committee is among us, Rui Ferreira. So this committee is promoting new experimental methods, instruments, measurement techniques, and also data analysis, either for studying fundamental hydraulics or other processes related to hydraulics, such as sediment transport. And the focus of this committee is on the on non-intrusive technical methods. And the last actually group that did with this topic is the IAHR group on reservoir sedimentation, which is actually a new group hosted by the Hydraulic Structures Committee of IAHR. And the main objective and the missions of this working group is to develop and share practical options for the management of sedimentation in reservoirs for long-term sustainability. Just to remind you some rules for this session. So from 3 to 5 minutes for to make the presentation. For attendees, you can ask questions in. You can write your questions, and during the coffee break, we will discuss together the different presentations. Will with Alessio, and we will give you feedback. And of course, we will answer. I will ask presenters to answer the questions asked by attendees. So we will start the presentation, the first presentation by Mutuma on the effect of land cover use changes on the Ethiopian Fincha Dam capacity. So please, you have from 3 to 5 minutes to make the presentation.
Okay, hello everybody. As I think you are hearing what I'm saying.
Yes, we are hearing you.
Okay. Good. Okay. My name is Motuma Ragasa. I'm a PhD student from Polish Academy of Science and Institute of Geophysics. My academic advisor is Professor Mikhail Nons. Today, my presentation is on the title of Effects of Land Cover Land Use Changes in the Ethiopian Fincha Watershed. Currently, Ethiopian Fincha Watershed is suffered by dramatic land use and land cover changes in recent years. So this study aims to analyze the land use, land cover changes in the Fincha watershed in the last 1 decade. Means that in this one short decade, we observed a lot of alters that is happened there. Means that from 2005 to 2015. During this one, thematic Landsat imaginary were deployed to categorize a land cover map of the steady watershed. When we come to our methodology and location for your awareness, the Finchara watershed is located in the Horo Guduru Walaga zone, Oromia regional state, Ethiopia, within or between the specified northing and easting. For this study, the input data, mostly spatial input data set, digital elevation model, and land use map. The digital elevation model is was freely downloaded from United States Geological Survey, and land use map of the study area was obtained from Ministry of Water Resources of Ethiopia and analyzed by using ArcMap, and the classification is carried out by the method of likelihood supervision method. Means that depending on the ground truth that is there around that area. Accordingly, as you have seen from this graph is the map of Finchara watershed, which has from its around 3 catchments, and that land is mostly covered by water body, forests, wetland, agriculture. Again, here what is there? Shrub land, settlement, and grassland. But these underwater, forests are classified according to their degree, sparse, dense, as well as moderate forests. Generally, when we have seen from the result of this one, or come to the result, the analysis of this one, forest or dense forest is totally out of the area mentioned in this Finchara watershed. Before, there is around 0.2 kilometer square. Again, moderate forest around 32, and sparse forest is 790. Each of them, when we come to dense forest, from 0.2 to after 10 years or 1 decade, it comes to 0.09, mostly that is declined. Again, sparse forest, before it is around 790, then it comes to after 10 years, 61.05, means again there is almost the change around this one. Again, for agriculture is used for annual crop as well as perennial crop. The land that is covered at 2005 is one by cropland or annual cropland is 1,279, but after 10 years it increased to 1,427. Again, the same also perennial before around 76, then it's increased to 1,000. This shows that the results indicated here was continuous and active land use, land cover change observed in the watershed for the last 10 years. Accordingly, the settlement area, water body, and cultivated land were increased by 1%, 3%, and 36, whereas grassland, shrubland, and forest land classes were reduced by 4.7, 10.9, and 25% respectively. By having this result, when we come to our conclusion, the study has quantified the land use, land cover change in Finchara watershed occurred between 2005 and 2015. The result showed that more than half of the forest was converted to other land use land cover types, while agricultural land increased significantly. Possible drivers of land use land cover changes in the area can be the expansion of subsistence and commercial agriculture, settlement of population, and sustainable exploitation of forest products and forest fires, as well as increase in human population, lack of proper execution of legal and institutional arrangements related to agricultural development and natural resource management. Behalf of this one, as a recommendation for the future, a proper and integrated approach in implementing a policy and a strategy related to land resource management should be considered, otherwise it will consequence another.
Okay.
Thank you very much for your attention.
Thank you very much, Motima, for this interesting talk. Now we will move to the second presentation by Giulia on the balancing flashing efficiency and duration proof of concepts.
Okay, thank you. Okay, good morning, everyone. I'm Giulia Stradiotti. I'm a PhD student from the Free University of Bolzano in Italy. And I'm going to present our work on balancing flashing efficiency and its duration. Sediment accumulation in reservoirs is one of the major threats to their lives. A common practice to manage this problem is drawdown flashing. However, it can be harmful for the downstream ecosystems proportionally to its duration. And also it forces a temporary stop on the production of hydropower energy. So we monitored a flashing carried out in Rio di Pusteria in South Tyrol in the northeast of Italy in May 2019. And we proposed some alternative scenarios through numerical simulations. Currently, flashing in Rio di Pusteria is performed every 5 years, during which more or less 500,000 of cubic meter of sediments deposit and then has to be released. We proposed 3 alternative scenarios with a lower initial sediment filling in the reservoir, in particular 25, 50, and 75% of the reference volume, which is the volume that corresponds to the current flashing periodicity. As you can see from the table, this means, of course, performing the flashing more frequently, even if with a shorter duration. From our results, we observed that there is not a linear relationship between the flashing duration and the initial sediment filling in the reservoir. And this is due to the fact that in each scenario, we had to apply specific maneuvers to the bottom outlets to respect the threshold on the outlet concentration, and also to the fact that a lower initial sediment filling in the reservoir implies a higher water content and so a higher inertia. However, in all the scenarios, we observed that the final water content in the reservoir was higher with comparison to the reference scenario. And in particular, we saw that looking at the 10 years framework, the 50% scenario takes about the same amount of day as the reference scenario, but it allows any time for a saving of 25% of the storage water. To conclude, even if it goes against the common practice, we saw that performing frequency with performing flashing with a higher frequency can be actually more convenient. Thank you for your attention.
Thank you very much, Giulia. Now the third presentation by Jorge on the efficacy of sediment flashing for different sediment mixtures. Jorge, it is. Are you here, Jorge?
Yes, I am here.
Yeah, please.
Okay, I am going to share the screen. Let me know if you could see that. Okay, can you see that? Can you see
Yes.
the presentation?
Yes, just can you make
okay.
it? Yeah, good. Thank you.
Okay. Okay, thank you. Good afternoon, everyone. I am Jorge Toapaxi Alvarez, and I am a doctoral student at the Universidad Politécnica de Cartagena. This presentation is composed by an introduction, methodology, results, and conclusions. As a brief introduction, the accumulation of sediments in reservoirs progressively reduce their storage capacity. And to prevent and mitigate these negative effects, several techniques can be used to evacuate sediments from reservoirs. This study focuses in the sediment flushing technique, which consists in evacuating the sediments from the reservoir by emptying it through the bottom outlets. The efficiency of flushing varies significantly depending on factors such as the geometry of the reservoir, the initial water head, and the sediment properties. In this context, this study aims to assess the efficiency of sediment flushing, varying initial conditions and for different sediment mixtures. As the efficiency is herein defined as the ratio between the volume of sediment evacuated to that of the water released. So the methods that we use, figure shows a sketch of experimental facility. It's a lateral view of the horizontal rectangular glass flume. The bottom was elevated to enforce critical flow at the downstream end of the channel. Upstream, the flume is equipped by a sluice gate to control the volume of water stored. Downstream, the channel is equipped with a tilting gate that allows a sudden opening and with a sediment trap to collect the sediments evacuating during the experiments. In this experimental setup, 3 different sands, so-called fine, medium, and coarse, were tested. The sands are characterized by diameter 50. Likewise, the figure shows HW, that it is the initial water head, and HS, that it is the initial sediment head. Moreover, for each sand, we ran 20 experiments by covering 10 values of the radio height of the water divided by the height of the sediment from the 1.25 to 5, and 2 values of channel length, 6 and 12 meters. The measurements consisted of lateral videos to characterize the evolution of the bed and the water surface during the experiments. Second, discrete monitoring of the water surface by means of ultrasonic denimeters. And the third, weighing of the sediment evacuated during the experiments. About the results showed a good correlation between the flushing efficiency and the parameter height of water divided by height of sediment, and cubic root volume of water divided by height of sediment. The first parameter represents the initial potential energy of the reservoir, and the other parameter represents the inertia of the reservoir. Therefore, it illustrates that the efficiency decreases as the initial potential energy and the inertia of the reservoir increase, irrespective of the sediment size. About the conclusions, within the range of the values adopted in this study, the influence of variables such as the initial height of the sediment and the initial water head on the efficiency of flushing is significant in comparison to the negligible influence of the sediment size. And finally, the efficiency of flushing is observed to increase for comparatively small water heads and for comparatively small reservoirs. Thank you for your attention. If you have any question, please let me know.
Thank you very much for your presentation. Now we will move to the to the third one. Sorry, yeah. So the fourth presentation will be done by Daniel on the ALS two-phase modeling of suspended sediment transport using a four-way coupled Euler-Lagrange approach. Daniel, are you here?
Yes, do you hear me?
Yes, please share your screen with us.
I think the preceding presenter has to stop sharing his screen because otherwise I'm not allowed to share my screen.
Okay. Jorge, can you remove sharing your screen, please?
Okay.
Thank you.
Okay. So now you should be able to see my screen. Is this correct? You see my poster?
Yes, Daniel.
Okay. So hello, everyone. Welcome, and thank you very much for your interest into my short presentation. We've just heard about the sediment management strategy of Flushing. And as some of you might know, that some sediment management strategies also involve dumping of sediments into a river. And the development of a sediment plume after dumping of sediment into a river is what we are actually ultimately interested when carrying out the research that I'm going to present you now. So we are trying to study the development of a sediment plume in turbulent fluid flow using a high fidelity computational fluid dynamics model. The model, on the one hand, solves the fluid flow based on the Navier-Stokes equations. And on top of that, also simulates the movement of individual particles based on Newton's law of motion. And the main point of my presentation now will be the validation of this model. So for validating this model, we've set up a little test case, which you can see a picture of in the first figure on my poster. So in the background, you see velocity contours of the turbulent fluid flow, and those black points represent the particles. So for validation of the model, we've continuously released particles from a point close to the inlet of the channel over a certain period of time. And after this injection stopped, we exported the positions of the particles and plotted them on such figures as you can see them in figure number 2. So this is the positions, the XY positions of the particles. X is obviously the direction of the flow velocity, and the gravitational acceleration is pointing in negative Y. So we fitted a regression line to those XY positions of the particles. And from the slope of this regression line, we were then able to calculate a sort of average fall velocity for the sediment plume. I've got a colleague who has set up a very similar experiment in a real physical laboratory flume. And he also used the same method for estimating fall velocity of his sediment plume. We've compared our results and saw that the results of the numerical simulation are within the range of fall velocities that my colleague has measured in the laboratory. So this gives us an indication that the model is actually more or less doing what we actually expected to do. So to round up my presentation, I want to give you a brief overview on how we are then actually planning to use our validated model to study the actual process of the development of the sediment plume in the river. So our real test case is slightly different than the test case that we use for validation, in that sense that we are not injecting the particles over a certain time interval, but we're injecting all the particles at one particular point of time, and also the range of particle diameters that we're using in the actual simulation is wider than in the validation experiments. And then from the results, we are, for example, extracting the velocity of fluid and particles. So the last figure on my poster shows on the x-axis the fluid velocity plotted against the particle velocity on the y-axis. For the x and z component of the velocities, you can see that the velocity difference between fluid and particle is pretty much symmetrically distributed about 0. For the y component, you can see an offset between the fluid and the particle velocity. Remember, gravitational acceleration is pointing in negative y, so this offset is clearly a result of particle settling. But in this part of the figure, you not only see the offset between fluid and particle velocity, but you also see that the distribution of fluid velocity is also somehow tilted towards the negative side, of course, speaking for the y component. And this gives us an indication of the influence of the particles on the fluid. So the moving particles exert a drag force on the fluid, and on top of that, fluid velocity is accelerated in negative y as a result of the density difference between the sediment water suspension in the area of the sediment plume and the lower density of the clear water surrounding the sediment plume. So this gives us another reason why we've got higher negative components for fluid velocity in the area of our sediment plume. So I hope this presentation could give you a brief insight into our research that we are working on. If there are any questions, please put them in the Q&A box and I will be very happy to discuss them with you at the end of our session. Thank you very much for your attention.
Thank you very much, Daniel, for your interesting presentation. And now I am inviting Preet to present his work on the influence of surge wave on carrying capacity and transport of microplastics.
Hello, everyone. I am Preet Patel from the Department of Civil Engineering, Lassonde School of Engineering, York University, Canada. My academic advisor are Dr. Magdalena Kroll and Dr. Shubka Karimpur. My research for my master's degree revolves around influence of surge wave on carrying capacity and transport of macroplastics. A total of 8.3 billion tons of plastics have been manufactured since the start of plastic industry. Of this, 6.3 billion tons have ended up in landfill and aquatic environment. Annually, 275 million tons of plastic waste is generated. Approximately 8 to 12 million tons of plastic waste enters aquatic environment each year, and 80% of aquatic waste originates from land-based sources. Now, plastic waste are carried to aquatic environment through various pathways. Rivers and coastal activities such as tsunamis, surge, and flood events are the key contributors which play a crucial role in transporting plastic waste from inland sources to aquatic environment. For my research, I will be introducing, for my research, microplastics will be introduced in a surge wave generated in an experimental hydraulic flume. Prior to COVID lockdown, we tested different flow rates, bed angles, that's a surge wave with a Freud number of greater than 1.5. And results are depicted in figure 3. Moving on to planned methodology. Multiple cameras will be mounted on the flume as shown in figure 1 and to capture microplastics behavior in a surge wave. Now, since the transport of plastic particles in a generated surge occurs within a few seconds, it is crucial to synchronize all 5 cameras to reduce pre-processing efforts. This will be achieved by connecting each camera to an individual single board computer, in this case Raspberry Pi, and with the use of an SSH connection, all single board computers will be synchronized, hence all 5 cameras will be synchronized, therefore enabling simultaneous recording across all 5 cameras. Data obtained from experiments will be analyzed using open source particle tracking velocimetry software, PTV research. Now, due to COVID, in-house hydraulic flume was constructed to experiment with PTV research, and planned results from PTV research can be seen in figure 2, where velocity profile was determined and unprocessed frames can be seen on top right. Moving on to conclusion. The anticipated outcome of this research is to comprehend the coastal transport of plastic waste in a surge wave, including surge wave carrying capacity, predicting plastic debris trajectory and velocity, and also possibly locating clusters of plastic waste. And finding may yield new insights and may also initiate further research to design better mitigation plan to improve aquatic environment. Thank you for your time. If you have questions, please put them in the Q&A session.
Thank you very much, Preet. The coming presentation will be presented by Bill on debris flow susceptibility assessment using the index entropy model in the visual catchment.
Good afternoon. Can you hear me, please?
Yes, we hear you.
Okay. Can I share my screen, right?
Yes, please share your screen.
Okay.
Your poster.
Okay. Let's get started now. Good afternoon, gentlemen and ladies. Debris flow is one of the most typical natural hazards in the mountain areas in Peru, which causes significant damages to people, fauna, constructions, and so on, thus affecting lives and the Peruvian economy. I'm Bill Sorrialiaga, a civil engineer and associate at the Institute for the Mitigation of the Effects of El Niño phenomenon, which belongs to the National University of Engineering, and a lead fellow at Royal Academy of Engineering. My colleagues and I decided to study civil engineering due to the large impact this career has in our country. And through the support of the advisor, we realized the quiet importance of mitigating natural disasters. That's why, as Institute, we're studying debris flow for more than 8 years in order to understand the behaviors and alleviate their effects. So one of our research studies is named Debris Flow Susceptibility Assessment using the Index Entropy Model in the visual catchment, performed by Giancarlo Escalante, Cesar Sanchez, David Gonzalez, Jefferson Castillo, and me. In this research project, geographic information system was applied to create a debris flow inventory map and maps of impact factors of debris flow, such as slope gradient, slope aspect, precipitation, normalized difference vegetation index, geology, and developmental stages of the visual catchment. Then, an index entropy method, which is a binary statistical model performed by Vesco et al. In 1980, was applied based on the work performed by Chen et al. 2017 and Wu et al. 2020 to calculate the weights of the impact factors of debris flow. These weight values were assigned to the classes of each thematic layer to produce weighted thematic maps, which were overlaid and numerically added to come up with the debris flow susceptibility map. And finally, a cross-validation IUC test was performed to assess the good of fitness between the actual debris flow and the prediction model, thus getting an encouraging success rate of debris flow prediction of 72.7%. Another conclusion is that NDVI, that is normalized difference vegetation index, and slope gradient are the most and less dominant factors influencing on debris flow events. Moreover, from the debris flow susceptibility map, we can check the extreme and high debris flow susceptibility zones are mainly distributed in the visual catchment on its right bank. It's important to emphasize that field research was performed to convert the data about the debris flow inventory map, which represents the actual data. All in all, it's essential to study this phenomenon, to understand its behavior and alleviate or mitigate its effects, thus building resiliencies for our society. Thank you very much.
Thank you, Bill. The second speaker is Don Wook on the experimental study on transport of microplastics in coastal sediment with an oscillating water tunnel. Bill, could you please remove sharing your screen? Thank you.
Thank you. Good afternoon, everyone. I'm Dong Hwang, master student in Seoul National University, South Korea. What I'm going to talk about today is an experimental study on transport of microplastic in coastal sediments with an oscillating water tunnel. This presentation is focused on the characteristics of transport of microplastics. First of all, then what is the microplastics? The plastic debris are ranged from 1 nanometer to 5 millimeter in size are called microplastics. Nowadays, the plastic pollution is very serious in coastal and marine environments. A huge amount of plastic waste has been entering the ocean, and most of them are returned to shores and coastal regions, and they are fragmented there. Although they are regarded as the main destroyer of the marine environments, there is dearth of research due to the complex mechanism for transport of these very small and fine plastics interacting with sediments and wave forcing. Therefore, this research is conducted to investigate the effect of the physical factor on that. The experiments has been proceeding using an oscillating water tunnel equipped with a detachable sediment basin. It can make waves with a higher order of the Reynolds number than two-dimensional wave basin. Also, it makes it possible to consider the only horizontal velocity only. In this experiments, sediment basin having 0.1 meter depth was used. Before the experiments, we utilize a particle imaging of velocimetry system, or shortly called it a PIV system, to access the newly built equipment. It is to estimate the precise flow velocity on the sediment basin and to observe the relation between the wave and the seabed. For that, a mixture of the two different sizes of PIV particle was used. One is 10 nanometers and another is the 20 nanometers respectively. The result can be shown in the figures number 3. We could find the boundary layer thickness of 1.7 millimeter and the free stream velocity of 0.028 meter per second in the steady motion. And then the mixture of the sediment and wholly plastic beads in the sediment basin was used. And the beads on diameters of 6 millimeter and 8 millimeter were used as substitutes of plastic debris in the experiments. The sediment basin was divided into 4 sections as shown in the figure number 2. Each section has 110 pieces of beach, in which the 100 pieces are in the sediments and the others are on the sediments. As a result, when the system is in the input velocity of 1 meter per second, the distributions of the beads are indicated in table number 1. It shows the smaller and lighter beads can come out of the sediments, and they move the both ends of the tunnel within about 2 minutes of the start. It talks the microplastic in the coastal environment can travel very far quickly, and the properties of the microplastics is very important to their transport movement. Actually, this research has not been completely finished yet. We are trying to find out the other properties affecting the transport as well. Moreover, the various size of beach will be dealt, and now we are used only 6 and 8 millimeter, and the effects of the roughness and bad form of the sediments are studied continuously. Thank you for attention.
Thank you for your presentation. The coming speaker is Daniel on the wastewater quality estimation through lead spectrophotometry by means of statistical models.
Sorry. And everybody can see the presentation?
Yes.
Okay, thank you so much. Well, first of all, good afternoon, everybody. My name is Daniel Carreras. I'm a PhD student from the Universidad Politécnica Cartagena here in Spain. And in this brief presentation, I would like to show some of the results that we have obtained in a search for a system that's enabled us to characterize the pollution load in the wastewater in a simpler and more economical way. As everybody knows, regulatory development emanating from the European Union in the last decades in the environmental field has placed emphasis on halter water degradation and combating illegal discharges. However, traditional method based on a punctual sample we are analyzing in laboratory with different chemical and procedure doesn't seem to be the best option to be able to have a real-time analysis of the water quality. In order to try to overcome this problem, we have developed an equipment that from an spectrophotometry analysis of the water sample within the range of 380 700 nanometer is capable of estimating parameters such as chemical oxygen demand or biological demand of oxygen at 5 days, among other parameters. This equipment can be located in the sewer network itself and work autonomously taking sample and sending this information to the cloud through Internet of Things and even Ethernet. One of the key aspects of this equipment is the fact that it doesn't require the use of incandescent lamp to be able to carry out the analysis. Instead, we have developed an spectrophotometry module based on LED technology that make it possible to characterize the sample more quickly and simply. And even with much lower energy consumption than the equipment based on incandescent lamp, and without the need to use on any optical element. That means which has allow us to reduce the price and the dimension of the equipment significantly. In this presentation, you can see an image of the equipment that we have created, as well as different parts that is make it up. However, beyond how the equipment is designed, the really important aspect is to know how this estimation has carried out. That is, how is find the correlation between the absorbance and transmittance value with respect to the pollution load present in the water. Well, this estimation is possible thanks to some calculation model we have obtained by means of a genetic algorithm from a campaign of samples made in a wastewater treatment plant located in the south of Spain for 2019 and up to the middle of 2020, analyzing about 200 wastewater samples. Thanks to the research carried out, we have managed to develop a series of models for the calculation of the following parameters, such as chemical oxygen demands, biological oxygen demand after 5 days, total suspended solids, phosphorus, total nitrogen, and nitrogen nitrates. These models are valid for both raw water and treated water without the need to subject the sample to pretreatment, and being valid for raw water with high concentration of chemical oxygen demand and biological oxygen demand after 5 days. That is higher than 700 milligram per liter and 450 milligram per liter respectively. And with treated water with chemical oxygen demand and biological oxygen demand at 5 days, value below 50 and 10 milligram per liter respectively. Well, all the calculated model for estimation of the water quality has shown an error less than 4%. The figures show an example of one of these models corresponding with the estimate of the chemical oxygen demand, where the blue line is the chemical oxygen demand value measured in the laboratory for the different sample and by traditional methods of analysis. The red charts represent the value estimated by the model during the training process, as well as the calculated with the test data. I mean, with data not used during the model generation process. And this is the blue one. Well, this model showed that it's possible to achieve a simpler, faster, and even cheaper system to know the quality of water and serving as a turning point with respect to the current model of analysis. I just want to conclude my presentation, mention that if somebody wants to have more information about this work, I invite you to check the following paper shown here in the screen. That's all. Thank you very much for your attention.
Thank you very much, Daniel. So we will move to the last presentation of this session by Rui, comparing LiDAR with common free surface measurement methods in aerated hydraulic jams.
Yeah. Can I share my screen now?
Yes, please.
Yeah. Can you see my screen?
Yes.
Okay. So I will. Yeah. Hello everyone. I am Riley. I'm the PhD student in the University of New South Wales in Sydney, Australia. And I'm presenting the study of comparing LiDAR with common free surface measurement methods in aerated hydraulic jams. Hydraulic jams are complex air water flows frequently observed in nature channels or used as energy dissipators in human-made hydraulic structures. The free surface of hydraulic jams is characterized by three-dimensional fluctuations, air bubbles, water splashes, as well as the strong interaction with the flow turbulence and internal flow properties. Different instruments have been used in physical modeling to understand the free surface properties of hydraulic jams. Intrusive instruments, such as wheel gauges, were traditionally used in air water flows. Acoustic sensors are not typical non-intrusive instruments that were extensively used in hydraulic jams. In recent years, a novel non-intrusive instrument, LiDAR, was explored in hydraulic research, which can measure the free surface continuously and with high spatial and temporal resolution, providing continuous and detailed free surface profiles. Although the comparison between previous studies using different measurement methods showed overall good agreement, there are still some gaps between different studies for comparable hydraulic jams, And this might be related with different experimental facilities or flow conditions because these experiments were not conducted simultaneously, so the flow condition was not controlled to be exactly the same. Therefore, to assess the performance of LiDAR compared to classical instruments and to understand the inconsistency between different studies, we compared LiDAR with acoustic displacement meters, ADM, and wear gauges simultaneously in the same hydraulic drums. So here, figure 1 shows the overall experimental setup in the present study. The water flows from the upstream tank into a laboratory flume, and then the hydraulic drum was generated in the flume. So we use the LiDAR to measure along the center line of the hydraulic drum, and we use ADM and wear gauge on each side of the center line with the offset of 0.07 meter. The hydraulic drum was simultaneously measured with these instruments for up to 30 minutes. So figure 2 shows 4 instantaneous free surface profiles extracted from the LiDAR measurements. So here we can observe the strong free surface motions within 4 seconds. And then we can see the detailed and continuous line for each time step. Well, the other 2 instruments, ADM and wear gauge, were not able to do that because they only measure at fixed locations of the sensors. The statistical results also show good agreement. The figure 3 here shows the mean free surface profiles and free surface fluctuations analyzed using standard deviation. The solid line and solid symbols represent the mean free surface profile on the left axis, and the dashed line and hollow symbol represent the free surface standard deviation on the right-hand side. So overall, we can see they compared quite well. And all these free surface properties were adjusted to the mean jump to location recorded by the LiDAR. So here we can see the average difference in the mean free surface elevation is about 17 millimeter, which is 13%. And the the average difference in the standard deviation is about 2.7 millimeter, which is 5%. So they compared quite well. Well, these relative differences in free surface properties might be related with different measurement principles. For example, ADM has comparatively larger footprint. So if we use ADM in the sloped section of the hydraulic drum, it will record the first signal return. So that's why it shows a little bit higher free surface elevation than the other 2 instruments. And wear gauge was intrusive into the water. Because of the dynamic flow motion, the water impinged onto the intrusive wear, and the wetting and drying time caused the higher free surface elevation measured by the wear gauge, especially close to the jump toe in this region. So apart from the similarity that we observed in basic free surface properties, LiDAR shows an advantage over the other 2 instruments in jump toe tracking. So previously, when we used traditional instruments to measure hydraulic jumps, we visually observe the mean jump toe location. But it's very hard to accurately select the mean jump toe location because of the strong jump toe movements. So here with the LiDAR measurements, because LiDAR measured continuously along the center line with high spatial resolution, so we can pick the instantaneous jump toe position at each time step. So that means LiDAR can track the jump toe location. So here figure 4 shows the jump toe oscillations within 20 seconds. So here we can see the strong jump toe movements around the mean jump toe location extracted from the LiDAR measurements. So overall, in conclusion, all the instruments can measure the free surface properties. Well, LiDAR shows some advantages in jump toe tracking, and it also has longer measurement range, which give us new opportunities in future studies to record in prototype structures. Thank you everyone for attending.
Thank you very much.
Yeah.
Thank you very much for your presentation. So we have ended the presentations for this session. Now we will move to the coffee break to discuss all together the different presentations. So I will let Alessio and Andrew animating this, chairing this this coffee break. Thank you again.
Okay, thanks.
There's a number of questions in the question and answers panel. Would you like to read them, Kamal, or
Yes.
should we see differently?
Yeah, actually, we received many questions. Some of them were already answered by speakers. Some of them not yet. So there is a question to Jorge about his presentation from Isabel Mora, asking whether he compared his result with the numerical modeling, with numerical simulations.
Okay, Isabel, we are working right now on the numerical models in order to compare the physical model data. Maybe right now we are going to apply the one-dimensional and maybe two-dimensional numerical model, such as HEGRAS or IBER.
Okay, and there is for you, Jorge, another question from Stefan. Asking, are you planning to, in your experiment, to use cohesive material?
Okay, right now, maybe not, but the 3 different sands were tested, fine, medium, and coarse. And now it is not planned to use thinner sediment, but we have tested 3 sands, which has a diameter of 50 equal to 0.39 millimeters. It presents some of the cohesive effect, and it is now planned to vary another conditions, like geometrical condition of reservoir. That's all.
And by the way, I have one question on your experiment. Actually, did you check? I mean, in your measurement, I didn't see any estimate of errors. So, did you appreciate a certainty in your measurement? Did you repeat your experiment to check the repeatability of your data?
Okay, we did 60 experiments in this research, but we use different measurements, but to compare and to validate the other methods. For example, we use the imaging processing to obtain the geometrical dimensions, and then we use the weight of the sediment to validate that the volume of the sediment that it is evacuated is the same.
Okay. Thank you, Jorge. There are 2 questions to Donwook. There is from Ariana Varani, who he provides a small notice that MP microplastics are defined as plastic debris smaller than 5 millimeter.
Yeah, thank you for question. Yes, you're right. Microplastic is ranges from 1 nanometer to 5 millimeter exactly. However, sometimes it is referred to entire range. Also, actually we conducted experiments using 1 to 2 millimeter diameter beads. However, there are some problems because the beads are very small and the sediments, and so we are considering the better method for my future work. Yeah, thank you.
And another question for you from Santiago. He is wondering how does your experiment can be extended to coastal and ocean water bodies? Because in this specific context, there are different drivers like Coriolis, and there are also stable stratification, effect of temperature, salinity. So actually they control the boundary layer thickness. So how can you link your work to the coastal and ocean context?
Actually, the I refer to the boundary layer is the result of the experiments with the without the sediments. And the 1.7 millimeter is the calibrated with the numerical solutions for the steady motions.
Okay, but the I mean your experiment is in which extent your experiment is representative of what is the context of coastal and ocean water bodies. So in terms of forces, in terms of temperature, salinity.
Yeah, the temperatures. Okay, thank you. I'm gonna check the in the future. Yes, thank you.
Okay. Question from Santiago to Willy for the use of the LiDAR.
Yeah.
How much was the successful read reflections from your equipment?
Yeah. Thank you for your question, Santiago. Well, for our experiments, actually the signal quality is quite good. We get only less than 1%, not a number value. So I got signal reflection over 99%. And I think the quality of the signal depends really on a few factors. First of all, is the flow aeration. So we find if the flow is less aerated, for example, it's not air water flows. If we use that in a clear water, then the signal will penetrate into the water. It might record some meaningless thing underneath of the phase surface. If your purpose is to record the phase surface, then it will not able to read the phase surface. So the flow aeration is one factor. And because in this study, we use strongly aerated hydraulic jumps with flow number up to 8. So that's why the phase surface is fully aerated. So we get quite good signal return, signal reflection at the phase surface. So that's one factor. And another thing is about the type of LiDAR. So I just see that Santiago used the LiDAR from SICK LMS400. I'm using another type of LiDAR from SICK LMS511. So the signal quality also depends on the wavelength, the laser light emitted from the LiDAR. So from what I understand, LMS400 has a signal wavelength of 605 nanometer. But for my LiDAR, LMS511, it has longer wavelengths. So if the wavelength is shorter, then that means it's less likely for the LiDAR to penetrate into the water. So actually, I think your LiDAR should get better signal return than my LiDAR in terms of wavelengths, but maybe it's about the flow aeration. Or if you want to promote or facilitate the signal reflection at the phase surface, you may want to add some matters into the water, like sand or particles. It will also promote the signal return.
Okay, thank you.
Because for my study, we are really interested in the LiDAR measurements in air water flows, and hydraulic jump is a typical air water flows. So I'm sure if you use LMS400 in another type of air water flows, for example, spillways, you will also get very good signal return. Yeah.
Okay, thank you.
Right.
Before we move on, maybe can I pick up from here, because I have a question to Rui Lee.
Yeah.
You have the same name as I have. It's Rui.
Yeah.
It's about the studies that have been out recently comparing LiDAR with other techniques either laser-based or acoustic-based. And one of the things is that it really depends a lot on the type of aeration, as you mentioned, a lot really. And you reduce a little bit aeration, but still it's strong enough. You start picking up bubbles, not at the surface, but underneath, a little bit underneath the surface. You still get good signal. You still get good reflection back. But you tend to underestimate the surface of the hydraulic jump. You get kind of an average of the where you get the lots of bubbles. Have you noted something that might not be so to reduce a little bit your assertiveness that LiDAR is really good? Did you check where in aeration terms is it really the top instrument?
Yeah, that's true. I fully agree. Well, one question is that for aerated floor, the free surface is not it's not just a tranquil free surface. It's not just a clear, steady free surface. It's fluctuating, and the definition of the free surface is not well, what is the free surface you want to measure? You mean,
there's no free surface. There's a mixture of air and water. So.
Yeah, there's not free surface. It's just a mixture of air bubbles and water splashes or water ejections. And so in this case, we are still investigating in this space. So we are trying to compare LiDAR with conductivity probe measurements. We're trying to find what is the exact elevation that LiDAR can measure? Like, what is the white fraction at that location? So, yeah, I think that could maybe answer your question.
Yeah, it's a good discussion still, yeah.
Yeah.
I have one question for Motuma about the dam. So you in your presentation you have shown that there is quite important changes in the catchment. So I imagine that this increases the sedimentation in the dam reservoirs. That's right?
Yeah.
So for this dam, is there any management strategy that are applied or performed to reduce the sedimentation? For example, flushing or excavation, or how did you manage sedimentation in this reservoir?
First, just we have to have some recommendation and teach or just how they have to use land management system around there, or the one who is handling this project or dam. Also giving another engineering techniques, maybe flashing, how they can flash that sediment since the land is changed or the forest is diminished from there, maybe some increment of runoff. That runoff may erode a lot of sediment to that area. This may have its own impact. So we will recommend, because this project is normally on starting time. Just we have discussed on this one. For future, we decided we plan to give such mitigation either of flashing, either mechanically or manually, or having some recommendation to how they have to have environmental handling system.
Okay, but the design of the dam itself is fixed now, or it is under a discussion to consider this management strategy?
Normally, before the dam is constructed, before 40 years or before 4 or 5 decades.
Okay.
But there is the decrement even on the reservoir or this reservoir capacity. As you have seen from the report or that presentation, the water body is increased. Okay. Why the water body is increased? Again, in that reservoir, another dam or newly dam is constructed in this last 1 decade or recently in before 8 to 10 years again. Thus will bring the increment of the water body as well as wetland. Even peoples, those are living around there is resettled to another place. This may, with including the increasing of population, will increase the settlement around there. This will normally affect the deposit or the sediment that's accumulated in that site, and actually that dam is affected. But behalf of us, still no recommendation, no mitigation. What we have gave is there because the project is on starting. Normally, that is started in this academic year. As initial time, we have done this, and for the future, we will give some mitigation that can be a solution for that. But the dams exist. The reservoir is actually impacted on the ground truth. This is what we have there.
Okay. Thank you for the explanation. Thank you.
Okay, thank you very much.
May I also ask a question to Bill, who spoke about this debris flow susceptibility? Roberto, sì.
Bill, are you here?
Yeah, I'm here.
Yeah.
Okay.
I was. I couldn't really catch it while you were speaking. You showed this comparison between the cumulative area of debris flow-prone areas and an observed one. The observed one was based on field survey, right?
The research, yeah, it was focused on a comparison between actual debris flow, which were obtained by an inventory map of debris flows, and it was compared with a statistical model. In this case, the index entropy model.
Okay. Now my question is: in your plot, there are basically two slopes. Because your points first define a large slope and then they are quite flat, if I remember it correctly. And now my question is, which is the criterion to accumulate the areas? Is it from the small ones to the big ones or vice versa?
Okay, about the areas. In this case, we base on the work performed by Cheng et al. We work with dividing in small areas of the visual catchment. Our analysis was based to divide it in small areas because visual catchment is about 20 square kilometers. It is in a big area compared to the work of Cheng et al., which is a larger area. I know, that could be. I don't know if I was able to answer your question, but
I was trying to understand why you have this behavior in the plot with first a high slope and then a small slope of the points. I'm not sure. I don't know if you have thought about it. Anyway, thanks.
Okay, thank you.
Can I make a question to Daniel? Daniel Wilt?
Yeah, sure.
Yeah, just discuss a little bit more the hypothesis and what you're actually doing in your modeling. I understand you use one of the versions of OpenFOAM.
Yes.
Very small particles. I was puzzled by the Lagrangian approach. These are really small particles. I don't suppose you actually resolve the flow around the particles. So you're probably using some kind of Maxi-Riley equation.
Well, we are not actually resolving the flow around the particles, but we are considering the momentum exchange between particles and fluid and vice versa, using the drag function. So we've got the velocity difference between each of the particles and its surrounding fluid. And from this velocity difference, we can calculate a drag force, which is the momentum exchange between the two components.
Yeah, but there's a large body of published papers and some investigations, even experimental, about what is really relevant when you're not actually resolving the body. And added mass, memory effects, all of these terms in the Maxi-Riley equation, they are there for some purpose because they are needed. It's not just driven by drag.
Yeah, but the mass is there as well.
Sorry?
The mass is there as well. So we have this buoyancy effect, for example.
Yeah, you have, of course, we have mass. The particles will have mass, but the added mass effect, the inertial effect of displacing the fluid when the particle needs to go, in there, perhaps you don't really have it, and that is something that would be relevant. So part of your explanation of the differences between the flow field and the moving particle, I'm not totally sure they are not side effects of not having the more sophisticated dynamics of the particle motion, basically including the terms of that might be needed since you're not resolving the flow around them, while basically solving the actual Maxi-Riley equation.
Yeah, so maybe we could take these extra terms into account then.
Yeah, I'll also make some investigation on what you find would be really the relevant terms, and there are several studies that will make an analysis of the the relative value of these terms, and what normally added mass, drag, and memory effects, they are relevant. Of course, second order effects, facts and terms, and all of that, maybe not. But at least these three, I'll say it's relevant. Yeah. And then, how many particles did you track? Were you tracking how many particles actually?
About 5,000, 5,000 to 6,000. So I also tried with more particles up to 60,000. But yeah, so 5,000 was approximately the number my colleague used in the physical laboratory. Okay. So I tried to imitate that.
Okay. And if you consider just, using, well, instead of a discrete model, just introducing, because these sizes, maybe it would be more relevant to just change the density of the fluid and make a two-phase flow model, but really based on difference on density rather than actual the motion of the particles. Because 5,000 for these diameters, they're not so many. It's not really sediment-laden flow, it's a few particles. So normally you have in suspended flows a lot more particles that would actually influence density. Is that a later objective of the work, or are you still planning on working on countable numbers of particles?
Well, I've also worked with a model where I used the Euler approach for both phases, so for the fluid phase and for the particle phase.
Yeah.
Of course, in this model, the only difference between particle and fluid velocity was the fall velocity. So it actually wasn't a real two-phase model then. It just added the fall velocity to the fluid velocity to get the particle velocity. And it also accounted for buoyancy, so for the extra density. But what I thought, the lower number of particles is actually an argument for using the Lagrangian approach for the particles rather than the Euler approach. So since I've not got a high number of particles, I can actually use the Lagrange approach and really have a more detailed velocity difference between particle and fluid rather than just the...
Sure. I agree. The problem is then the practical applications. It's very rare that you have very few small particles in an actual flow. I mean, some industrial flows, maybe in nature, it will be very rare. That I would say would diminish the application of the model. Yeah.
Well,
Thank you.
The volumetric, so for this test case that we're then actually using, not the validation case, but the test case, we're placing all the particles initially towards the top inlet of the channel. And in this area, we've got a volumetric particle concentration of about 5%. So the initial particle plume is actually quite dense. But then, of course, density decreases due to the dispersion effects when the plume moves through the channel.
Yep. Okay. Thank you.
Rui, there is a question from Isabel to Jorge about the scaling of the experiment. Jorge, did you consider the similarity of Froude number or Reynolds number in your experimental setup?
Okay, our model doesn't replicate any prototype, and therefore our sediments are not scaled. We are trying to generalize the method, and we are studying the parameters that influence in the efficiency of flashing. But we are not considering any prototype in this study.
But I note that when you present your results, you present a result in terms of non-dimensional form, which is a good thing. I mean, when you present your results. So although your experiments are not representative of prototype cases, but in the description and in the analysis of the results, you use non-dimensional terms, so which is a good idea.
Yes.
I would like to. Yes, please.
Okay.
No, go.
Okay. Thank you. I have a question for Daniel. I was wondering about the range of solid concentrations for your research project, because I know that some technologies like spectrometry have certain limits, and moreover with fluids which have a non-Newtonian behavior. For example, like tailings, like Davis flow, which implies high concentrations. And so when a flow have high concentration of solids, there are certain techniques that are not able to apply on those flows. That's why we have to considering another Newtonian models and so on. That's why I was wondering about the range of solid concentration for your experiments, Daniel. I will appreciate your answer. Thank you.
So this was again a question for me. Yeah.
Yeah,
yes.
I was wondering about the range of concentration of solids for your quality of your flow, of your study flow. Yeah, I was wondering about the concentration of solids by weight, to be more specific, because there are concentrations of solids by volume as well. Yeah, I was wondering about the range.
Yeah. So the highest volumetric concentration is obviously at the start of the simulation, when we place all the particle in, it's actually a 2 centimeter edge length cube at the inlet of our channel. And there we have got a volumetric concentration of about 5%, and the density of the particles is 2,500. So it's trying to imitate the natural sediment. And then obviously as the particle plume evolves, the density, sediment density gets less and less.
Oh, okay, thank you.
Yeah.
Can I ask something to Julia? About the flushing efficiency and the work about especially the outcome, the conclusions. It would be more convenient to flush more, possibly less volume. I was wondering if your study is going to move into a less hydraulic and more econometric kind of way, because to probably just to make this kind of conclusion, you probably have to weigh in several uses of the water, and this what is really relevant for the stakeholders around the reservoir. So I didn't really get where do you just struck this very assertive, well, not totally assertive, but this clear conclusion. Can you explain a little bit more? How do you handle, or you plan to handle, the many stakeholders around the usage of the water of a reservoir?
Okay, so the study is made mainly by the perspective of the company owner. So the convenience is expressed mainly in terms of the convenience of the company owner in this case. So what we saw is that usually owners of companies doesn't like to perform very frequent flushing, because anytime they lose days of production. But we saw that in a 10 years framework, so not just considering one flushing, but considering a period, a decade, if we double the frequency of flushing, we use more or less the same. We lose more or less the same amount of production production days, and every time we perform a flushing, still we save 25% of water stored in the reservoir. And this is specific, of course, of the reservoir that we studied. Is not possible to extend the result to all the reservoirs, but it could still be possible in this case to derive water during the flushing. So since the level of the water in the reservoir doesn't go below a certain level, it could be still possible to produce energy during the flushing. So that's convenient. And on the environmental perspective, we, based on the fact that it was proved that the impact of the flushing is also connected to the duration of the exposure, usually is evaluated as the product, let's say, of the, it's a persistence, so the product between the concentration and the duration of the exposure. So performing more frequent flushings that are shorter can also be less harmful for the ecosystem downstream. And for instance, also for the, I don't know, for the fishes compound. So if we saw that the fishes can survive a flushing for a certain amount of days. But if we shorten up the flushing, the chances of their survival increases. So.
Yeah, thank you. But let me just add one small note that dam owners tell me when they do this, they say it's risky to do this. Bottom gate opens and it might not go back. Something might get stuck, and then they will lose really a lot of water. And so they try to, minimize the times or the number of times they do this. At least they tell me that.
Yeah, I don't know, because for instance, during the flushing that we monitored, they didn't just open the gates and that was it, because they had also to respect a threshold on the concentration in the outlet. So they have to open the gates and close the gate anytime they see that the concentration is going up, is going over a certain threshold. So I don't know, what we saw dealing with some companies was that they are not, the idea is try to postpone the problem later and later and later until you have to flush the sediments that you have inside the reservoir.
Thank you.
Thank you.
Okay.
Yeah.
Sorry for cutting this, but we are out of time. I think that
Jose, if we are out of time, Jose, just let me just say one thing to Danielle. I probably told something. Yeah, we're discussing, but I really like the work. There's a number of tests that I have with larger particles, with which I'd like to see is model performing. Because I do like the work. I ask these questions, but for even larger particles, I think it will be even easier to get good results. So I'll probably try to be in touch. But thank you very much.
Thank you for your comments and your suggestions. I've actually run the model also with larger particles, but then they settle quite fast to the bottom. There is not a lot.
And then they bump on the ground, and that's even more difficult. Yeah, thank you.
Yeah, thank you for your comments anyway.
Thank you very much. I think that it has been a really interesting session with a lot of participants, a lot of feedback from your part. Thank you, Rui. Thank you, Kamal. Thank you, Alessio. And thank you, all the participants. So right now, we are going to move to the next session of flow risk management. This session is going to be driven by Stefan Hahn from the University of Stuttgart, and later we will have also Benjamin De Waal from the University of Liège during the coffee break. So Stefan, when you want, the floor is yours.
Thank you very much, Jose. Good afternoon, everybody, and heartily welcome to our session in flood risk management. As Jose already said, my name is Stefan Hahn. I'm the head of the hydraulic laboratory at the University of Stuttgart, and later on my colleague Benjamin De Waal from the University of Liège will accompany me to discuss and to have a joint coffee break. We are both members of the Committee on Flood Risk Management of IAHR. We were funded in 2015, maybe a few small words and a little bit advertisement. So we are quite a huge society. And what we want to do, or what is the aim of our committee, is that we want to have a platform for members of our community to have an exchange. I think it's very important in our field that we are having the link between theoretical achievements and also solving practical flood-related problems. Due to climate change, I think we all know that we have more and more severe flood events. Storm Alexander hit, as example, Italy and France just a couple of weeks ago. So I think it shows already the importance of our committee. So if you join IAHR, or if you're already a member and you're interested in flood risk management, we would like to welcome you to our technical committee. A few small things, just how we deal with the session. The rules, I think, are clear to all speakers. It's about 3 to 5 minutes. I will take care on the time a little bit. In the same time, if you have questions to the speakers, please post them, put them in the chat, or put them in the question and answers directory. Last but not least, for all people who attend here and later on for all speakers, please do not forget to insert the virtual background into your background so that we all have the same corporate identity. In this case, I would say I talked a lot so far, then I want to give or hand over now the word to Vincent Verdonk. He's from the University of Twente in the Netherlands. The floor is yours.
Well, thank you, Stefan. We'll try to share my screen here. Yeah, I hope it is visible right now. Yeah, okay. Well, so thank you, everyone, and welcome and thanks for attending my short presentation. My name is Vincent Verdonk. I'm from the University of Twente. from the Netherlands, and I have investigated the residual dike strength of earthen levees, also known as dikes. Well, first I will provide some basic backgrounds related to this topic and how we deal with this in Holland. So by Dutch law, main failure mechanisms of dikes need to be assessed and comply with defined failure probabilities. The failure mechanism instability across the landside slope is one of these mechanisms by which a dike can fail. Well, this mechanism prescribes the loss of stability of a mass soil and is caused by a high load, such as a high water level or just a high load on the dike itself. Well, advanced models are quite capable of assessing the risk of this single mechanism, and it is expected that this risk will increase in the future as a result of climate change. Well, however, instabilities alone do not only well, a single instability often does not result in a dike breach alone. Often, follow-up dike instabilities are required, as was found by Mark van der Kocht et al., which would eventually lead into a dike breach. Well, alternatively, it is also possible that a dike breach after an instability can occur as a result of wave overtopping, as is depicted in the diagram right here in green. Well, to assess this risk of erosion by overtopping waves, so waves that top over the dike and erode the backside of the dike, we have developed a framework to assess the remaining strengths by wave overtopping. This framework is evaluated, by considering different water levels, wind distribution, to come up with the overtopping load distribution with all the volumes that flow over the dike. By using this analytical, by using these volumes with the analytical equations of Van Bergijk, we can obtain some insights into the failure or the erosion depths that will develop at the backside of the dike itself. And this was performed for a dike case, this was at the Rhine River, where the Rhine River enters the Netherlands from Germany, just where it splits off to the Waal River section. Well, let's see. Okay. Oh yeah. So we have evaluated this framework, and by performing this model like 10,000 times for different characteristics like the wind distribution and the grass cover strengths, we obtained with a Monte Carlo analysis an insight in the failure occurrence at different water levels, and this can be seen in a fragility curve, as is shown in figure 2. And from these results, it can be seen that the failure probability decreases rapidly for an increasing difference between the heights, the free crest height, so the height between the dike top and the water level itself. So what also can be seen is that dikes with dike instability seem to fail more frequent at an increasing free crest heights. And third, it can be noticed that the clay cover quality has major impacts on the failure occurrence itself. And this failure occurrence seems to increase at a rate of 2 times or 12 times higher, depending on the actual cover or the clay quality that is used. So now for the final conclusions, this research has shown that the residual dike strength after a dike instability is still really significant, and as an advice, we As a result, we advise to evaluate beyond the initial failure phase, and thus to integrate the follow-up mechanisms within future approaches. Well, thanks. That was my presentation.
Thank you very much, Vincent, for the very interesting talk. We will go to the next presentation immediately to Javier Fernandez Pato. Is he in the room? We have not seen him so far. If not, then we would continue with Ukwabai Gesesef. I hope I pronounced your name correct. Otherwise, please correct me. He's from the University in Berlin in Germany.
Okay. Okay, thank you, Stefan. My name is Olay from TU Berlin. My title is Statistical Analysis of Precipitation. Are you hearing me, Stefan?
Yes, we can hear you and we see your presentation.
All right, good. My title is Statistical Analysis of Precipitation Data for Hydrological and Hydraulic Modeling of Flash Flooders. Here I have 2 or 3 objectives. The objectives are identification of trend. Second one is probable maximum precipitation analysis using frequency factors. And the last one is testing of outliers in the data. Then again, I follow 3 procedures or 3 methods in order to achieve the 3 objectives. The first one is non-parametric man-candle trend test for trend identification, and the second one is for probable maximum precipitation analysis. I used frequency factors, that is Gampel method and log Pearson type 3. And the last one for outlier test, I used Graps and Beck's method. To proceed to the results, the statistical parameter analysis parameters are analyzed with non-parametric man-candle trend test at 5% significance level for the time series precipitation measurement from 2000 to 2019. The data size of the data is around 6,939 data point. Then the results, the maximum value of the data is 59.73 millimeter. The minimum is 0. Mean 1.5948 millimeter. Standard deviation 4.6923. P-value is 0.001 and alpha is 0.05. Alpha is a significance level. Then the probable maximum precipitations were analyzed using Gampel and log Pearson. These are the values are summarized here for 10, 50, 100, and 200 years return period. For Gampel, the maximum discharge for 10 years is 55. For 50 years, it's 71 millimeter. For 100 years, 77. For 200, 84 millimeter. Again, for log Pearson type 3, 10 years return period, 53. For 50 years return period is 65. For 100 years return period is 69. 200 years return period is 74 millimeter probable maximum precipitation. To proceed to the conclusion, as you can see, the values as the computed p-value is 0.001, is lower than the significance level alpha 0.05. Then we can say the null hypothesis is rejected because the value of alpha p is less than the significance level alpha 0.05. Then we can say that there is a significant trend in the data. Then we can accept the alternative hypothesis because of the null hypothesis is rejected, or the p-value is less than the alpha or significance level. And the second one is the peak values. As you can see from this table, in the case of log Pearson, they are a bit lower, or in the case of Gampel, they are a bit higher. Then this is because of the transformation or standardization of the data from using logarithmic or natural logarithmic. And the last one, outliers are tested. As you can see, the result is there is high outlier. The high outlier is 68.4 millimeter, and the low is 20.74 millimeter. Then these are identified and removed from the data because it has an impact on the fitting of the data or for further analysis of the data, especially for the flood forecasting and flood prediction. As you can see, this is a data size. It's around 6,939. There is a significant rate, but because of the bulk of the data, we cannot see the trends. Or you can see these are the peaks. Okay, then there are an incremental and decremental trends in the data. This is my presentation. Thank you. If you have any questions, you are welcome at the end of the session.
Thank you very much for the interesting talk. And as already mentioned, if you have questions, please write them to the question and answer Paul here, and we will discuss them then afterwards in the coffee break. Thank you again for the presentation. Let's move to the next presenter. It's Lena Ferstel from the University of Natural Resources and Life Science, also called BOKU in Vienna. The floor is yours.
Thank you very much. So I'm going to share my screen. Okay, so I'm going to talk about the evaluation of floodplains along the Danube in Austria with the floodplain evaluation metrics, a comparison of 1D and 2D models. Within integrated flood risk management, it's very important to preserve the remaining floodplains, and due to the conflicting needs of different sectors like flood protection, ecology, and socioeconomics, we have to be able to evaluate floodplains and their importance for each of these sectors. To do this, we can use an integrative approach, the floodplain evaluation metrics. It provides parameters for each of these sectors, and we can use the parameters to assign performance classes of low, medium, or high. Many of these parameters are based on hydrodynamic modeling results. So in this case study, we looked at a stretch of the Austrian Danube where we still have extensive floodplains, but due to run-of-river hydropower plants, they are separated from the main channel by dikes, and the inflow to the floodplains during a flood event really depends on overflow sections. We used results from different models to apply a simplified evaluation approach where we focus on hydrological parameters only, the flood peak reduction and the flood wave translation. The models are a HECROS 1D model and a HECROS 2D model, which serve as alternatives to HydroS 2D models. And all three of them are based on the same DTM and calibrated to observed retention during the flood event of 2013, which exceeded 100 years flood. So from the 100-year simulations, we used the outflow hydrographs to calculate the parameters. And in accordance to defined thresholds, we then assigned high performance to both parameters and all models. So the results were actually quite similar. You can see in the figure that the colored hydrographs are the three different outflow hydrographs of the models. Our general conclusion is that it is possible to sufficiently reproduce retention effects of certain floodplains using also these tested alternative models and to apply the FEM evaluation. But for 1D, I have some comments. So on one hand, the calibration approach that we used seemed kind of promising because we balanced the roughness values in the floodplain with the assignation of ineffective flow areas and the coefficients of the lateral structures, which we used to model the overflow sections. On the other hand, the unsteady simulations and heterogeneous flow situations in the quite large model produced instability to a high extent. Additionally, there are, of course, uncertainties regarding influences of other model parameters on the retention effects, especially regarding the simplified incorporation of weir geometry and gate operation of the hydropower plants. Since the lateral overflow at certain flow rates depends on the water level in the impounded sections, which has to be reproduced in some way. So yeah, that's from my side, and thanks for your attention.
Thank you very much, Lena, for your interesting talk. I'm looking forward to the questions to the talk. So once more, again, for all people, just ask your questions in the questions and answers poll, and we will respond to that in the coffee break. The next speaker would be Usman Khalil from Wollongong. So that means he is from Australia. It's almost midnight there, and I have not seen him in the room. If he's here, maybe a sign. And if not, then we would continue with the next speaker. The next speaker would be Patricia Mai Paraiso. I hope I pronounced your name correct. It's also evening there because she's coming from the Philippines. So Patricia, the floor is yours.
Okay, I will share my screen. Oh, sorry. Can you see my screen now?
Yes, we can see your screen.
Okay, so good afternoon there and good evening from the Philippines. I will present our study entitled Assessment of Land Cover Changes of Marikina Watershed, Philippines to River Runoff and Flooding. This is part of the Coastal Cities at Risk project of the Philippines, and my colleagues and mentors are Liz del Castillo and Doxelin Vicente. So Marikina Watershed is located east of Manila in Luzon Island in the Philippines and has an area of 535.5 square kilometers. Back in 2009, Typhoon Ketsana, known locally as Ondoy, caused destruction in the watershed. Marikina River overflowed and caused flood. And flooding in the parts of the watershed was repeated in the next few years, especially during the wet season. Also, over the years from 2009 to 2018, 17.7% of this area was converted. 33.27 square kilometers was urbanized, leading to 4.5 increase in impervious surface. Because of this data, the study investigates how land cover change would affect flood characteristics of a Typhoon Ketsana type rainfall by comparing flood model results of 2009 and 2018 land cover inputs. So for the methodology as shown in Figure 1, basin models of 2009 and 2018 were generated using HGeoHMS extension in ArcGIS 10.3. This contains the soil data, topography, and land cover. HGeoHMS 4.3 of the Hydrologic Engineering Centers of the U.S. Army Corps of Engineers was used for the two rainfall runoff models using land covers of 2009 and 2018. In comparing the two scenarios, precipitation from Manila Observatory Station and estimated discharge from the water level of Marikina River in Santo Niño Station were used as constant. HECRAS 5.0.3 was used for the 2D unsteady flow analysis to develop the flood model maps. The hydrograph models from rainfall runoff circulation were used along with the topography and geometric mesh for the floodplain. For the resulted hydrograph, as shown in the screen. Sorry. Okay, there. The graph includes the precipitation, which are the yellow bars. The green line indicates the estimated discharge from observed water level. The red line for the 2018 data, while the blue line for the 2009 model. As you can see, the models have the same pattern, but increase in peak discharge and flow volume for 2018 were observed. The Nash Cliffs coefficient model efficiency was used for validation. NECs for 2001 was 0.64, while 2018 was 0.71. So the models were considered satisfactory. For the flood maps, the satellite flood maps was also shown in figure 3, with increasing flood depths from yellow to red. Highest flood depths increased 0.04 millimeters and extent widened by 7 square kilometers for 2009 model. Largest deepening will happen in upstream along the river banks and some downstream areas. These were validated by comparing the model maps from NOAA, flood hazard maps, which are available, and flood reports from Quezana, from the citizens. For the conclusions, the land cover changes, especially the increase in areas converted to built up, raise the risk of flooding downstream. Thus, forest cover should be protected and vegetal cover should be increased by reforestation and allocating green spaces in the watershed. It is also recommended that land cover change be considered in flood mitigation and disaster risk planning. Also, hydrologic and hydraulic modeling are effective tools in visualizing the behavior of river and flood. This can be used in decision-making and planning the early warning system. Also, we can model future scenarios which using downscape climate projections on projected land cover. So this will be good in decision-making and policy recommendations for the local governments. So thank you very much, and I hope I can answer your question later.
Thank you very much, Patricia. I'm sure you can. Therefore, we are collecting questions. So let's come to the next speaker. It's Giuseppe Pisaturo from the University of Bolzano. Giuseppe, the floor is yours.
Oh, thanks. Hi, Stefan. I share my monitor. Okay, hope that you see everything. So my presentation, my poster, it is about procedure for human safety assessment during hydropeaking events. The idea is that usually when we study hydropeaking, we are focused on mainly two topics. The effects of hydropeaking on habitat, doesn't mean on fish and on macrobenthos, but sometimes we forget that we have other aspects that are connected with hydropeaking, and one of these it is the human safety. For example, in Italy, happens very usually that sometimes some people goes inside the river for recreational purpose or stay near the banks. When the flow rate is very small, these people can reach the central part of the river, but the increasing of the water flow due to the hydropeaking cause an entrapment of these people inside the river itself. And so the fireman needs to be called to save these people. Sometimes they are able to do this, sometimes it's finished with the death of these people. So we want to study how to investigate if a river affected by hydropeaking is safe or not. To do this, we have two steps in the method of this approach. The first one, it is an hydraulic simulation of the hydropeaking wave. In this case, we use, for example, ECRAS 2D. In the second part, we apply the discrete algorithm that wants to analyze which is the minimum path, so the minimum length of the path that you need to leave each cell of your computational domain, and to leave this river doesn't mean to arrive to the nearest bank. As you can understand, this algorithm is based on the distance between two cells, but this distance is not only the distance in meters between two adjacent cells, computational cells, but depends on some penetrative function. These penetrative functions are three types. Let me say the first one depends if there is a presence of a steep uphill between two cells. The second one depends on the presence of trees or brushes or big boulders. The last one, it is the most important, it takes account of the hydrodynamic limits. Doesn't mean the product between the water depth and the flow velocity in each cell based on the Bischoff method. So higher values of water depth and flow velocity, this product doesn't mean that it is more difficult to leave each cell and move from one cell to the other. The results are very interesting because obviously in the central part of our river, we have the highest value of escape difficulty because we have higher velocity, the velocity of the flow and higher water depth. But another important results is that if we see this image, for example, the second part, that is an example of the pattern that one people have to do to leave the river is, let me say, not easy to do. Someone can think that given that this starting point, that is where I have my cursor, is near to the left bank, the easiest way to reach the left bank, but it's not, in this case, is not this one. A person should reach the right bank, given that in this direction he can minimize the escape difficulty, because in this part of the river we'll have lower water depth and lower velocity. So the results can be used in two different ways. We can use the result to understand if a river is safe for human safety during hydropicking events. We can use also to, for the firemen, for example, to perform some maps to understand how to recover the people that are blocked, that are trapped inside the river. So the easiest way to recover these people. And finally, to understand if the usual hydropicking mitigation measures that are operational one or morphological one can be also efficient and be used also for minimize the human risk during hydropicking events. If you have some questions, I'm here later, so I'm finished and thank you for my time.
Thank you very much, Giuseppe, for an interesting talk. We will move to the next speaker. It's Adina Moraru from the Norwegian University of Science and Technology in Trondheim, Norway.
Yes, hi everyone. I'll share my screen. Can you see it?
In my case, is your microphone open? You're quite...
I'm sorry, I forgot this.
Now it's perfect.
Thank you.
Thank you.
Thank you very much. Do you see my screen?
Yes.
Perfect. Let me get into this. Yep. All right. Thank you, Stefan, for introducing me. So I would like to show you an overview of my PhD research, which focuses on the optimization and visualization of numerical models of flash floods in steep Norwegian rivers. The main motivation why I want to focus on optimizing models is because, and then later on visualizing them, is because we would like to work on presenting more relatable or more in a more user-friendly way results of flood risk to the population, and we would like to engage them a bit more. And it's quite challenging, but I think it would be quite interesting to create a game where we can present several scenarios, and the user can actually play around and learn something through the game. And so to do so, we would need very fast models that could iterate or compute along the way, so in real time while the user plays. Well, no one likes to wait while playing, so we need very fast ones. I don't know how fast we can get, but we're working on it. So one thing that we have done is that there was a recent flood 3 years ago. There was a small village in the west of Norway that flooded, and we were lucky enough to document the flood in the field. And although the catchment is very small, let me see if I can yeah, here I have a laser pointer. Although the catchment is very small, it's 25 square kilometers, and we focused only on the most downstream ridge, which was 700 meters long, because it's where the population is agglomerated. We have tried to have a 2D model that is very fast in this small test case. And we have tried parallel CPU computing. We have tried both single thread and multi-thread and of this 2D hydrodynamic model. And we have done so also on GPU. And we have explored a bit with machine learning. We have simulated a 1D convolutional neural networks model. Although the data is still to be analyzed, I can show you a small, short sneak peek into the comparison of the performance of CPU computing time versus GPU computing time. You can see this in the figure B. So the blue bars are GPU computing time, and you can see that they are much lower than the CPU computing time. And it's on the order of several seconds. It's less than 10 seconds per time step. And whereas on CPU, the red bars are the single thread and the green, black, and orange bars are the multi-thread. They are much higher, they are much slower. But we also have learned that the dispersion of the data is obviously, as seen here, much larger on the CPU models than on the GPU computed models. Now, one thing that we have noticed is that we have obviously more threads on a GPU than on a CPU. We had up to 4,000 threads on a GPU sometimes, whereas in most of the CPUs that we tested, we had less than 8 threads. So obviously the number of the threads that are available in the processing unit will condition how fast the model can be. Now, we wanted to also compare these GPU results, which were obviously faster than the CPU ones, with machine learning model, but we don't know yet how reliable the test was. So although this has to be, still processed and analyzed, I remember that the machine learning model was faster, although the learning in the training process was very slow. Now we need to also analyze, of course, the precision of the data. It would be interesting to have a model that also shows where we could protect the river and protect the population, so decision makers can also use this game to obviously make decisions. And that's it. That will be basically future work. We would like to test these things. Thank you very much. If you want to know more about the project, you can scan this code here, and a bit more about my research is in the other codes. Thanks.
Thank you, Adina, for the very interesting talk. Let's move to the next speaker. It's also a speaker from the Norwegian University of Science and Technology. It's Nitesh Godara. Nitesh,
thank you, Stefan. Can you see my screen?
Yes, yeah, now we can see the poster.
Yeah, hello everyone. So I also work with the same project which Adina just explained. So my part is to do hydrologic modeling, and this study is about coupling of hydrodynamic and hydrological modeling. And the model used for this study is Telemark 2D, which is originally a hydrodynamic model, but it also has an option to include a hydrologic module in it, so that it can be extended to a hydrodynamic rainfall runoff model. This hydrologic module is based on SCS curve number method. The study area is very steep and very small, having total area of 10.5 square kilometers, and it lies in Western Norway. The effect of various parameters are investigated, such as the effect of steep slope, effect of various ANC conditions, and the effect of varying mesh size in the river and also in the rest of the catchment. So first of all, if we talk about the effects of changing the ANC conditions and the curve numbers in the catchment, the model responded well as it was expected. That is, Increasing the curve number throughout the catchment gave the higher runoff volume, and changing the AMC conditions from from wet conditions to dry conditions decreased the runoff volume. According to few past studies, increasing the catchment slope leads to an increase in the runoff volume. But in this case, the effect of applying the steep slope was only significant in the beginning of the simulation, as we can see in the figure number 3. Now, if we look at the figure number 4 here, when the mesh size was changed from a finer mesh to a coarser mesh, the model was unable to catch the more precise runoff volume, but the simulation runtime was drastically decreased from more than approximately 3 days to 18 hours, which is quite fast in terms of hydraulic perspective. And the final simulation results are shown in figure number 2 here. The setup for the simulation is mentioned here. It shows that although the model responds to the rainfall correctly, but the results for peak discharges are not very good for the coarser mesh size. But considering the results from figure 4, it can be said that the volume of the water can be made more precise with a finer mesh size. And this is just a preliminary study using the Telemark 2D model as it is, and it did not work as we wanted for the steep catchments. So for the future work, we are planning to implement other hydrologic models and methods, including a snow routine in the current Telemark 2D. And in addition to that, the aim will be to further reduce the simulation runtime. So that's all from my side. Thank you everyone for your attention.
Thank you very much, Nitesh, for the interesting talk. Let's move to the next speaker. The list is almost over, but I heard meanwhile that Javier Fernandez Pato entered the room. He's from the University of Zaragoza in Spain.
Hello.
Hello. The floor is yours.
I'm going to share my screen. Okay. So good morning, everyone. My name is Javier Fernandez, and I belong to the Computational Hydraulics Group of the University of Zaragoza in Spain. What we do in our research group is to develop numerical models to simulate natural environments as mountain or river flows, especially under transient conditions. Today, I'm going to present one of our latest work regarding the simulation of hydrological and morphodynamical processes in a particular mountain catchment of the north of Spain. So the basic idea is to develop a bidimensional numerical model able to consider the water flow at the surface, which will be generated by the incoming rainfall, the infiltration through the soil, and the sediment transport by means of erosion and deposition processes. This model is based on the shallow water equations in 2D, which provide an accurate way to deal with this kind of transient flows. For each computational cell, we have to solve 3 equations of conservation of mass and momentum with 3 variables, which are the water depth and the unit discharge in both directions, X and Y direction. In the right-hand side of the system, we have source terms of rainfall, infiltration, erosion and deposition rates, bed slope, and friction in both directions, X and Y. I would like to focus in this work in the infiltration processes, because we have developed a new model, a modification of a classical model, which is the Greenland infiltration model. And what we see with this model is we are able to improve, significantly improve the results from previous studies. Finally, the last equation we have to consider is a conservation law for sediment transport, or suspended sediment transport. The full system of equations is applied to a bidimensional domain by means of a triangular flexible mesh. In order to test the accuracy of the model, we integrate the water and sediment discharge at the outlet of the watershed, and we compare these numerical results with the experimental values. This data is provided in the reference number 2. We can see in the plot, in the right part of the poster, that the experimental points are represented by the dots, and the numerical results by the dashed lines. We have two different results. In the upper part of the plot, we have the solid hydrograph, and in the lower part, the liquid hydrograph. And we present the results from the classical Greenland model and the new Greenland model we have developed based on fractional calculus. And we can see that the improvement is significant. We also can get the conservation of total mass, even for the sediment, which is difficult. And of course, another conclusion is the application of this model to large domains, as this one is not a problem anymore, because we have modern computers with GPU techniques, and we can simulate a large domain in a few minutes, like in this case. So thank you very much for your attention, and any question is welcome.
Thank you very much, Javier. I think I called you Jose first, and you didn't tell me.
No.
I'm sorry for that, but as you already said, questions are there for the coffee break. Please post them in question and answers. Thank you once more for your presentation. And we have one more speaker. I already announced him. It's Usman Khalil from the Wollongong University in Australia. So it's already very late at night.
Hi. Can you see my screen?
Yes, we can hear you and we can see your screen. Hello.
Hi. My name is Usman Khalil, and I'm a PhD student at the University of Wollongong. I'm conducting my research on the Brisbane River for flood adaptation measure and water resource development. And in today's presentation, I will be presenting flood disaster and adaptation measure in Brisbane, Australia. And the figure 1, you can see Brisbane River catchment area. You can see the Brisbane River catchment area is divided into two parts, upper catchment area and the lower catchment area. In the middle of the Brisbane River catchment, there is Ivanhoe Dam, and in the lower catchment area, there is Brisbane City. Brisbane River has a history of flooding, and the recent disastrous flood happened in 1974 and in 2011. After 1974 flood, the government proposed the construction of Ivanhoe Dam, and the dam was successfully to regulate the upper catchment area of the Brisbane River. However, in 2011, when excessive rainfall happened in the catchment area of the Brisbane River, the Brisbane city flooded heavily, and the flood disaster caused loss of lives and infrastructure. And after this flood disaster, many studies proposed flood mitigation measures. For example, flood mitigation dams, levees, flood mitigation gates, but they could not implement any study due to public resistance. This study proposed an innovative coastal reservoir technique at the mouth of Brisbane River estuary in Moreton Bay. You can see this is the Moreton Bay. So along with the reservoir and its operational gates, this study see the adaptation of flood level in Brisbane River. How is this study performed? This study used Mike 21 hydrodynamic model. The Mike 21 hydrodynamic model is set up for Brisbane River estuary and Moreton Bay. After the setup of model, the model is calibrated and validated by adjusting the input parameter and Manning roughness coefficient. The model is successfully calibrated and validated, as you can see in figure number 2. The statistical performance coefficients results were quite good and quite satisfactory. After that, what we did, we have inserted dike and gates. There were 3 gates, 2 gates as the inlet, gate for coastal reservoir water and outlet gate for coastal reservoir outflow water. And there is one gate that really controls the flow of water inside the Brisbane River estuary from the Moreton Bay. Now, the operation of gate depend on the water level in the Brisbane River estuary. When the water level would be low, the coastal reservoir intake gate will remain closed. And as the water level will start rising at the Brisbane city beyond safe flood level, then we will start opening the coastal reservoir intake gate. And at that time, what we will do, we will also intermittently open and close the tidal gate, because when there would be low tide, we will keep this gate closed and open, and when there would be high tide, we will keep this gate closed, because due to the confluence of riverine and tidal flow, the flooding also happen in Brisbane River estuary. You can see the cross section of this gate in the figure 3, gate A, B, and gate C, and the operation of gate also in D diagram. What we have found that we have performed 2 scenarios. Under scenario number 1, we have operated the coastal reservoir under the normal flow releases from Ivanhoe Dam. And we found that if we optimize the gate operation, a flooding level in Brisbane City gauge station could be reduced up till 13%. And then in the second scenario, we have seen that when we open the gate and there is improved management of Ivanhoe Dam at upstream, then under this improved management of Ivanhoe Dam, the flooding at Brisbane City Gate can reduce up to 28.3%. So how this happened? Due to the opening of gate, there would be no more tidal resistance. And as we open the gate, there would be a drawdown in the water. As we have increased the intake of the river at the intake point of coastal reservoir, this would create a drawdown which help in reduction in water level in Brisbane River estuary. So this research is still in development, but we have found that this potential coastal reservoir can be used for flood disaster mitigation, and further this water can be used for water supply also. Thank you.
Thank you very much, Khalil, for the interesting presentation. By the way, in 2011, the IAHR World Congress was hosted in Brisbane. So we were there short after the flood event. Short means we were there in June or July 2011. And I was also on the excursion to go to the Ivanhoe Dam. So there we can see how small the world is.
Okay,
good.
That's interesting.
Thank you very much to all speakers for the very interesting presentations. In this case, we are very good in time, so all speakers kept the time limit. That is very good, especially for us as chairs, because we don't have to intervene. The coffee break or our social gathering starts in roughly 8 minutes. So I would say let's make a short break for grabbing a coffee or doing some other business, and then we will meet here in 7 minutes for the discussion. Meanwhile, if you have questions, please also post them. What I saw is Lena, for instance, she's already answering the questions, which is also a possible feature here in the chat. In this way, I would say we meet in roughly 5-6 minutes again. And for the discussion, I would like to ask the speakers to turn off also the cameras, that we have a nice overview on all the speakers. Meanwhile, I would ask, is Benjamin already in the room?
Yes. Hello, Stefan.
Hello.
I've been following all the talks.
Perfect. I think very interesting talks.
Yes, indeed. Yes, I'm looking forward for the discussion.
Me too. So by the way, is Usman, I think, is the first name, or? I cannot hear you there. Your microphone is off.
Yeah, Usman is my first name, yeah.
Okay, so I always called you wrong. Sorry for that.
No worries.
Usman, can you also stop sharing your screen? Then maybe we get a bigger overview or a larger overview on all the people in the room. Perfect. Thank you very much. I already see that Jose is back.
Yeah, I'm here.
Patricia is also here with us. One question, Jose, are we planning to make then a screenshot or a picture from all the participants?
Yes, the secretary is going to take picture, but yeah, of course you can also take pictures.
Good. Why now we see your email posts? You wanted to share your screen?
Yes. No. Sorry. Ah, my goodness.
I think we have all the participants right now during the session. So you can start when you want the coffee break.
Perfect, good. There was a question from Adina that she cannot write questions. But maybe we can start with that. Adina, turn on your microphone and then you can ask directly. We don't hear you.
Thanks. So as I have noticed that we're encouraged to ask questions, and I like to do so during the presentation so I don't forget. But for some reason, I can only answer the questions that someone else has asked before. But I don't have a blank field, so I don't know if it's for everyone or just me. One question that I would like to ask the chairs is, can you think of what the current main challenges are in the field of flood risk management?
Benjamin, do you want to give an answer?
Okay, so we start right now with a very tough question. I hope the complexity of the question will not increase gradually during the discussion. So, but by the way, that's a tiny question because Stefan is more involved than myself, but with the committee, we are preparing newsletter. And one key part of the very first issues of this newsletter will be to discuss ongoing challenges, and there are, of course, many of them. I would be happy to discuss a few of them, but probably we are not going to cover all the aspects. Yes, for instance, you mentioned the communication, the engagement of stakeholders, and that's definitely a very big issue. There are all those aspects which are related to the interactions between the physical system and the human system. It was also mentioned in another talk related to the safety of human people close to the river. There are major uncertainties in the whole chain of flood risk modeling, and those uncertainties they are only partly taken into account so far. I think that it's not a critic, but when you look at many of the graphs that were displayed during the session, uncertainties, they were not often displayed explicitly, at least. Okay, so it's a very key aspect, and those uncertainties, they are everywhere. They start from the meteorological data, with the model parameters, model structures, with the data on digital elevation models, for instance, that were used by many of you. And then, of course, when you move to damage modeling, to the impact on the economic impacts, and uncertainties tend to become even more important. So that's a very brief overview. And so, Stefan, do you want to provide some more comments? Probably we could talk the whole half an hour about this question.
I think half an hour would not be enough, to be honest. No, it was very good summarized from you, Benjamin. Thank you very much. This is exactly also the question where we would like to incorporate our community in that. So we started a newsletter series. It's called Advances in Flood Risk Management. So I have volume here on my desk, but it was not published so far. So it will be handed out to the whole community within the next days and weeks, I hope so. And this is one goal what we have as a committee, like to share this knowledge and also to collect these ideas. So what we do in the first step is that Daniela, she's the vice chair of our committee, she's setting up more or less an online tool where we can insert all these open questions, so all these uncertainties, all these things, what is missing, so that the whole community is collecting this, these weak points in flood modeling or risk assessment. So as Benjamin said, it's not about half an hour where we could fill in. I think it's much more. So our goal is like to collect all these things and also to distribute these things with the community, because I think everybody has the same problems. When he or she starts to develop a model, why not collecting all these things, bring them together in an online portal or somewhere else, benchmark data sets and so on to collect these things. And as already mentioned at the beginning of the session, so if you would like to participate, please feel free to do so. Everybody is welcome to put in ideas. Very often, and this is also when I was at the beginning of my career, I was always thinking about, oh, this may be a stupid question, I will not ask it. But I think there are no stupid questions, there are no stupid inputs, because with every input you can get out something interesting of it, and you have to incorporate it. Good.
So I would agree. Thank you very much, both of you.
You're welcome.
Welcome.
Should we go around? Are there other questions? So please feel free. This is a very open room where we can share thoughts, where we can discuss things.
There seems to be a question to Usman, which has not yet been addressed. In your study, the natural factor of high rainfall or changes in land use cause floods? Question mark. So, shall we ask Usman to display the screen again?
Okay, to display my screen. Is that okay?
Yes.
Yes.
Okay, the question is how flooding happened. If we talk about 2011 flooding, 2011 flooding happened due to excessive rainfall in the Brisbane catchment area. You can see the flooding happened on 13th of January. And at that time period, the 6 days rainfall in 2011 was approximately 25% of the annual rainfall of 2011. And the January rainfall in Brisbane River catchment surpassed the average rainfall in January by 117%. So you can say it was due to excessive rainfall in the catchment area, this flooding happened. Hopefully I have answered the question.
Mm-hmm.
Yes. There's also a question to Ukubai. Yes. Second talk. Where is rainfall data obtained?
All right.
How many rain stations are used?
Yeah.
How does the trend of rainfall in your study area in the long run either indicate an upward or downward trend? Yes, indeed. There was a trend, but in which direction?
Okay, thank you for the question. My study, actually, this is part of my PhD research. I am studying in the northern part of Ethiopia. And I got from the northern, there are regional states that's called Tigray. I collected from 3 stations. Then the next is, what is the trend in the long run? There are both upward and downward trends in the data because it's long for 19 years data, but I took a base value or threshold, I established already a threshold value to extract the data for analysis. The size of the data is very large. It's around 6,939. Then it's a little bit difficult to show you here, but there are both upward and downward trends.
Okay. And by the way, which is your interpretation of those trends over a relatively short time series? Yes, I think the time series that you showed in the poster was roughly 1 decade. That's correct?
2 decades.
2 decades, okay.
19 years, 19, yeah.
Yes, okay. So do you have an interpretation for those trends that you find out?
What do you mean in terms of what?
In terms of attribution of the reason for this trend over just 2 decades.
I'm not clear. Can you clarify it more a little bit?
Do you have a hypothesis on the main reason?
Yes.
Yes.
I have already a hypothesis. The assumption in the null hypothesis is there is no trend. That means if P is less than alpha, if P is less than alpha, there is a trend. But if P is greater than alpha, then there is no trend. Then this is a hypothesis for null hypothesis. If this is not true, then what comes next? The alternative hypothesis. That is, P is less than alpha, then there is a significant trend. Then I verified that, or I tested the hypothesis. Then finally, since P is less than 0.001, alpha is the significance level is 0.005, then there is a significant trend in the data.
All right. Okay. Thank you very much. So there's another question, which is probably for Adina.
Okay.
The question is, are there other initiatives that make flood risk information more community friendly or easier to understand by ordinary people, like apps, simple dashboards available with open access, for instance? We can't hear you.
course. Thank you. So actually, we are focusing on having a virtual reality-based game. But I have noticed that there are many other initiatives where they try to use augmented reality, which enables you to use your phone and to walk around the river or near the river and see extra information in your phone in the screen as you scan your environment, which is very easy to handle because you don't need then the goggles or a special equipment. And I think that makes it also usable in real time on site, right? So I think that could be something. Also having early warning systems also that are connected to your phone, so you can easily have notifications, and that the population can use to get training, but also to know when to react, right? I think this is something that could be quite useful. There are many other projects that are doing this. We're currently focusing on virtual reality, but this is something you can have in a computer, but you can also implement way easier in a tablet or in a smartphone.
Okay, thank you. And there are many initiatives in this direction.
Yes.
And actually, you didn't display 3D results in your poster. You didn't display the results in a 3D form, but that's one objective that you have.
Yes, we have that as a common project, but there are several PhD theses within the project simultaneously ongoing. And so I don't work on the quality of experience and gamification, and nor I do the psychological factor, which is the risk perception. This is something that we have in the project, but is not my main scope. So that's why I did not dare to focus too much on it.
Okay, so you focus more on the computational efficiency.
Exactly.
And I had a quick question on this. How similar are the codes that you tested on the CPUs and the GPUs? Usually you need to recode the model to have it run on the GPU. Can you comment a little bit on how similar? I guess you aim to solve the same equations with more or less the same complexity, so that the two types of runs on CPUs and GPUs can indeed be compared. But, do you have comments on this?
Yes. As a matter of fact, I have tested both on CPU. I have tested both full momentum, which is I tried this on HICRAS. It's open source, open access, free access. Yeah, it's very easy to use. And I have tried this also on, but that was with a quadrangular mesh, and I have tried this also on a triangular mesh in a software called IAHR. It's a Spanish developed software by the Polytechnic University of Catalonia in Barcelona, and the code has been already translated. They have worked on this recently, and the code has been already translated to CPU usage. So this is something that many of us can use. I didn't really implement this myself. And so the comparison during the CPU and GPU was performed in the same software with the same numerical scheme. Simply the processing unit that was computing was a different one allocated in the same computer. So the GPU and the CPU were exactly in the same computer, and the numerical scheme was the same. The model setup was identical. So that's why the main focus there was to compare the computational speed.
All right, thank you. Maybe a small suggestion. Something I didn't see in the poster was the computational time divided by the number of threads. And
yes.
That's something which is relevant.
Yeah, like I would call that parallelization efficiency. I'm not sure if that's the right term, but I would call it something like that to see how efficient every thread would be, right? I am working on this, and I have this in a longer manuscript, as we were limited to 2 pages. I did not dare to include more details, but it's a very good suggestion, actually. So yes, I have also worked a bit on this. Thank you.
Very good. When we talk about early warning systems and about psychological effects, then maybe if I'm allowed, I would directly switch to Giuseppe, because I think these are 2 topics which are very close correlated. Because also Michael Nones, for instance, asked the question, hi Giuseppe, in your model, have you done any consideration regarding the human characteristics, child, old, citizens, etc., and behavior on the escape paths? So I wanted to bring this question. It's already answered by Giuseppe, but I would like to bring it inside once more to the auditory to also discuss about these things, because I think psychological effects are quite important, or aren't they?
Yes, you are completely right. This aspect is very difficult to understand and to analyze in our analysis in any case. And the things that we have done is in any case to have these results, perform the results both for a child and both for adult people, because these two types of groups of people have different characteristics against the hydraulics penetrative function. Typically, obviously, for child people are more easy, that could be drift during the flood events, so during let me say in this case a hydro-peaking wave, and other peoples are more resistant, more or less like fish. It is more or less, it is the same. It's brutal to say, but it's quite similar. So for these two categories, it's possible there exists already in literature different parameters, not for old people or categories. After, obviously, it's not possible for now to consider the fear of the people during these events. So how can be they react when the hydro-peaking waves arrives, and if they are able effectively to choose the right direction to escape from the river. To do this, an idea could be to perform some mitigational measures, morphological one, that want to increase the ability of these people to join and to reach some part of the river that is safe, and avoiding that these people want to reach other part of the river that are completely unsafe.
Mm-hmm. Did you also think about implementing an early warning system? I think it's not that nice if somewhere in the nature people want to have it very quiet and suddenly you get a very loud signal from the hydropower plant. But is that an option in your case? What do you think about that?
Could be an option, depends also how much far are you from your other power plants. I mean, because for example, in our case, the other power plants was more or less 5 kilometers upstream. Mm-hmm. So in any case, the sound should be very, very loud. And I don't know, someone want to propose to put in the water some color, for example, for a few minutes. In this way, if you see some different color in the water, doesn't mean that hydro-peaking wave will arrive very soon.
Okay.
Maybe on the same topic, there's also the concept of warning wave, where it's used at different places, including in the Alps in France. So the first release is gradual, so that it induces significant change in the flow conditions in the river, but not strong enough to cause danger. Yeah. So that people see the water level is increasing by, say, 10 centimeters in just a few minutes. Something is happening, I should leave, but it's not so strong that people are really put in danger. And then after time, you have the real wave arriving from hydro-peaking.
Yeah. This can be done if you have another power plants that works with, for example, multiple turbines that you can arrange different flow rates. Otherwise, for example, for some types of turbines, it's very difficult for the manager to work with the different flow rates. Sometimes it could be that they have to open everything and stop. Otherwise, it's not possible to modify the flow rates.
Thank you very much. I would have another question also to Lena, maybe if I'm allowed, Benjamin, then I will go ahead. There was already the question in the forum and Lena already answered it, but I would like to come back again. Where is she? Here she is on my screen. My question would be, what is the benefit of a 1D model compared to the 2D model? Because usually 1D you use when you have very long river stretches, when you want to reduce simulation time, when you have very fine, or let's say you need to go to transects or something else. What would be in your case the benefit of using the 1D model compared to the 2D model?
The idea to use a 1D model too was that it would also be applicable in regions where they don't have a lot of data to produce a 2D mesh. My research here is part of a project of the whole Danube, where the idea was to really evaluate all the existing floodplains along the Danube. And a lot of project partners there used 1D models to do their study and their evaluation. And we wanted to kind of check if the results would be comparable. And also, well, with HECRAS, the idea that it's also a free program to use, and that's the same idea with the 1D HECRAS.
Okay.
Maybe another question to Lena. The 100-year flood seemed to have central position in your study. Is it actually the case, or do you also consider more extreme scenarios than this 100-year flood?
No, in this case, we only used the 100-year flood to make it comparable. Also with the study for the whole Danube, that really each floodplain is evaluated with the same with a 100-year flood wave. Yeah.
Okay, so somehow it's the transboundary nature of the study which forces to accept some simplifications so that you keep the results comparable from one area to the other. Probably. When you talk about the whole Danube, it's not only in Austria.
Yeah, exactly.
Yes. All right.
I would also have another question to Vincent. Where do I see him? When you were talking about the dam breaches, about the clay content or the quality of the clay, and also about the free crest height, what would be your solution for the future to deal with that problem? Because I think the findings in your study are quite significant when we think on climate change.
Yes, so for the future, we would like to do more experiments on the different kinds of clay qualities that are available within the levees to actually, well, test how reliant they are and prone against erosion by overtopping. And these kind of overtopping tests are also actually performed on Dutch dikes by big wave overtopping machines. They put them on the dike and they have like a lot of liters of water in there, and they let it flow over. And like after a specific amount of repetitions, they measure the erosion that's on the dike itself. So with the ongoing tests of those experiments, we hope to be built in more reliance on this residual dike strength, and maybe also in the future integrate these kind of approaches into the safety assessments.
More or less, it's an approach also like for the future refurbishment of the dikes, that you are coming up with solutions. What could be the goal, or what has to be taken into account at least?
Based on these findings, you would really take into consideration like what kind of dikes, if they are actually probably the different kind of compositions, because of sea dikes, they have quite a regular composition of mud or clay that is within there. But often the river dikes itself, they have a very various compositions, so like 10 meters apart. They can be made up of very different materials, and sometimes it's not clay. It can also be peat or just a lot of sand. And well, knowing more about that and the risks that that could have will have a large impact on the safety assessments of those rivers. So, yeah.
Okay, that is quite interesting. Thank you very much.
Yeah, thank you for your question.
Maybe once more the question to all of you is anybody who has a question for somebody else, or? Because otherwise I would ask Javier about his catchment, because I read that it's a quite steep catchment. I don't see him here anymore. Javier, are you still here? If not, then we will write the question in the question and answer sheet. But who still is here is Patricia. I will also have a question to you. When you talked about the typhoon, I was wondering about the return period, because in your poster I saw you talk about 5 years, 25 and 100-year return periods. So I was a little bit wondering what was with the typhoon. How can you rate this event?
I think the return period of Ondoy is 50 years. Once every 50 years. Yes. That's according to World Bank study. But so I just included all the hazard maps.
Okay, but do you also consider it like land use change during the years from 2009 to 2018? What you recommended? Is there still a lot of surface sealing ongoing, or did that stop after such events?
Sorry, can you repeat the question?
Yes, you were also talking about land use change or sealing of surfaces. And what you did, you simulated 2009 and 2018. So there happened a lot of sealing, as far as I understood from your poster. Is this continuing in your country, that surface is getting sealed, or are people aware of this problem?
Yeah, so the land cover change is the forest cover is decreased so much, and there are changes also from forest cover to grassland, but most of it is to build up areas. So for these land use plans, the local government has comprehensive land use plans for, I think, for every 10 years. Yes, but I think the land use plans are good, but the problem is the implementation. So most of the plans are not well implemented. And there are also policies like NIPAS Act, like protecting the forest cover, but over the years it's not well implemented also. And sadly, we experienced again another Ondoy like recently from Typhoon Ulysses. So Marikina watershed also had flooded areas, and they said that some residents in the area said that it is worse than Typhoon Ondoy.
Perfect. Thank you very much for the answer.
Stefan,
yes.
Can I ask a question?
Sure.
You mentioned that you visited Brisbane after the flooding, even in 2011.
Yes.
So what was your experience? Did some studies regarding flood mitigation measures, or it was?
The only thing, I think, Benjamin, were you also there at the IAHR Congress in 2011?
I wasn't at this one.
You were not. We just visited the Wivenhoe Dam, and for us it was very impressive to see the reservoir there, which was filled, and people told us that before this huge flood event, it was almost empty. So the problem, or I would say Brisbane, that was at least what they told us when we were there, has a problem with drinking water supply, because the water level was so low, and they were already thinking about using sewer water to produce drinking water out of it. And then suddenly it was full, and this was more or less the only thing what I took as take-home message, because everything else was already refurbished. So we didn't see any damage or anything else. But when we were standing there at this reservoir and we saw that it was full and the size of the reservoir, what you could not even see because it was so large, and they told us before this event it was empty, then I think in this moment you really realize how big such events are and how harmful they can be. So that was more or less the take-home message I took with me.
Yes, that's true, because there was millennium drought from 2001 to 2009, and the Waivanho Dam water level reduced to 17%. And in that time period, this government started desalination plant and wastewater recycling plant for water supply. But suddenly in the end of 2010 and the start of 2011, there was excessive rainfall and flooding event. And this is how climate change worked in Brisbane. Yeah, that's true.
And I think this is more or less almost a perfect closing word, that we have to be aware of it. Benjamin, would you like to say something at the end of our session?
Shall we go for a quick question to Nidesh, who you presented this nice coupling between the hydrological and hydraulic modeling with Telemac 2D.
Yeah.
I was just a little bit surprised by the downstream boundary condition that you mentioned. You said you prescribe a water level. Is it actually a water level? Does it correspond to some structure, some weir, which does control the water level?
Water level was actually we gave precipitation data as input data.
Yes.
As a heatograph.
And then on the poster, you mentioned a downstream boundary condition.
Yes.
As a water level.
Yes, it is water level.
Which you don't know in advance, or do you? In principle, it depends on the computations, on the amount of, on the flow rate. It's not so important. You should take a close look at this.
Can you please repeat the question?
I mean,
just a comment.
In the poster, you list the boundary conditions.
Yes.
Data, which are indeed rainfall data, and you also mentioned a prescribed water level, I think, downstream. Okay, does it correspond to a real structure which is able to control the water level, or is it just a simple assumption?
No, there was no structure there.
Okay.
Yeah, it is not controlled.
Okay, maybe you should take a close look at this. A bit surprising.
Yeah,
okay,
it was not controlled.
Okay, so Stefan, so I think we have been discussing at least a little bit each of the posters.
Exactly. Unfortunately, the time was quite short, but I think if you would like to stay in contact, or if you have further questions, just email to Benjamin or to me. We would be happy to answer your questions. We would like to stay in touch with you. I think now Greg and Rosea are already in the room, so I think we will make some space for them. Thank you very much to all participants in this quite interesting session. It always is a huge motivation kick to see what is going on out there, and also to see how good quality the work has, which is performed. So thank you very much from my side.
Thank you very much.
Thank you.
Looking forward to see you around.
Thank you, Stefan and Benjamin. Thank you for driving this session, this interesting session. I'm sorry for not having more time for continuing the coffee break. Thank you to all the participants and the audience. And right now we are going to continue with the schedule with the following session related to ecohydraulics. In this case, in this session, we are going to have as mentor and chairs Gregory Pasternak from the US Davis. We are also going to have Gotthong Nguyen from the River Engineering and Urban Drainage Research Center in Malaysia, and also Roser Kasar Mulet from the Technische Universität München. So when you when you want, the floor is yours.
Thank you. So this is Greg Pasternak. It's really nice to be here this morning and see the presentations from our emerging new scientists in ecohydraulics. You know, so much about scientists really does involve community. It's easy to get focused on just the details of the research that you're doing, but having a support network of peers from your age group and older peers, and then ultimately younger peers when you get to my age, it really is tremendous. It's super important. And although it's hard to not be in person at the same time, we get a lot of benefit. I can talk to you from anywhere in the world right now. So it really is important. And so I think with the ecohydraulics community, we really do have a lot of growing connections that are really meaningful and important. And I really encourage you to take advantage of the opportunity to get to know the peers that you see giving their presentations today, because when you can draw on support from these people, like not just people at your institution, but independent people, your life that I really think is valuable. So without further ado, let's get on with the session. And I'd like to, I'm going to introduce the first four speakers, and then we're going to switch off from there. So for the first presentation, we have Mariam Farzako talking about attracting silver perch into a tube fishway.
Thank you. Good morning, all from Sydney at 1 a.m. So I will share my screen to have the poster. Have you got the poster? Can you see it on the screen?
Yes.
That's great. So let's start. My name is Mariam, and I joined UNSW Water Research Laboratory as a PhD student in 2019. And today I want to talk about how we can attract juvenile silver perch, native Australian fish species, into an enclosed entrance system like a tube. So as you know, fish requires different environment at some stages of the lifespan to spawn, to refuge from harsh environmental condition and some sort of things. But dams obstruct their fish migration path. Constructing different types of fish ways can be solution for these kind of barriers. Researchers from different disciplines of ecology and engineering in University of New South Wales came up with an innovative solution, which we call it UNSW Tube Fishway. So it has been designed and under development at the moment. Actually, this UNSW Tube Fishway can facilitate fish migration in a safe manner between for the heights between 2 meters and 100 meters. So the key process here is attracting fish into tube fishway, which is the focus of my research study. As you can see in figure 1, you will find that all the experiments has been conducted in an open channel flume. In the left part of the open channel flume, it is where the attraction diameter is placed, consisting of a slot with 3 centimeters slotted entrance and a skylight on the top to provide illumination for the fish. So the flow comes through from left to right, and flow comes to observation zone through the slotted entrance, and then left the open channel flow from discharging pool. The idea was investigating different attraction flow velocity to find the most suitable attraction flow condition for fish, and also to see if we can even attract fish into a tube or not. So different attraction velocities between 0 to 0.5 meter per second has been tested, and also water depth has been kept in at 80% of the attraction diameter, which was 0.4 meter. And then actually fish were inserted in the observation zone without any attractant flow, only to acclimate fish, and after 1 hour that the attraction flow was introduced, and the fish entry and fish movements have been recorded and monitored for another 1 hour. So the results, we found that that fish can be successfully attracted to different velocities with the best and highest entry rate at 0.15 meter per second. In figure 2, you can see different, the accumulative number of fish inside the tube, the fish that entered into the tube and stayed there for all the duration of the experiment for velocities of 0.15, 0.4, and 0.5. As you can see, the highest entry rate has been achieved for 0.15 meter per second, and the red line shows that the 5 juvenile silver perch can be attracted and can tended to stay longer in the tube with this flow condition. From the table, we can understand, because we have tested also another additional configuration to more streamline the entry for fish by blocking the right and the left corner of the open channel room next to the slotted entrance to streamline the entry for fish. So we found that streamlining the entry increased the entry rate. As you can see in the table, it is 100% entry rate, and also reduced the first entry time and improved it by up to 28%. Also increasing the flow rate reduced the entry rate for fish, which highlights the importance of providing low attraction flow velocity for these kind of fish species. So to sum it up, yes, it is possible to attract fish into an enclosed entrance system. And then this research is ongoing by testing different scalability of the tube fishway, by testing different diameters, different attraction diameters and fish sizes. And even we are trying to expand to different native fish species. Also in parallel, a prototype employment of the tube fishway is in preparation. Thank you for your attention, and I hope you enjoyed the presentation.
All right, thank you very much for that. So we've been taking some good notes to have some good discussion after the session. So we should move on, I think, or I'm sorry, are we supposed to have a time for a question, one quick question now, or move on? Should we just, I think we just move on, and then we'll save the questions toward the end, I think. Yeah, okay, just make sure. Sorry about that. It's early in the morning. Okay, so the next presentation is by Lisa Schmolfoss, talking about least disturbed rivers in the Altai Mountains can reveal environmental guiding principles. I remember reading this, and I immediately went on to Google Earth. I had to go look at this place, the Bia River. It was just really stunning. So I was kind of excited to hear about this. Go ahead.
Thank you very much. I'm just going to share my screen. I hope everything works. Can you hear me, by the way? Yes. I hope it works. Yeah, perfect. Should be there. So the work I'm going to present to you today is the starting point basically of my master thesis. The focus is, as already mentioned, the hydrogeomorphological characteristics of the Bia River in the Altai Mountains in Russia. And the reason for that is basically that due to river straightening, channelization, severe alterations in land use within the catchment of all larger rivers in Central Europe, the hydromorphological characteristics of the affected rivers are changed. And nowadays, the need to restore these, the ecological functionality is widely accepted. In order to successfully plan sustainable river restoration measures, environmental guiding principles are needed, since it's next to impossible to find suitable reference sites in Central Europe One approach is to look elsewhere in less densely populated areas, like in this case, Siberia. And the Bier Mountain, the Bier River can be regarded as a least disturbed hydromorphological reference system. And the basic assumption of my work is that a hydromorphological assessment of the Bier system can reveal those environmental guiding principles for alpine rivers, which have comparable characteristics to the Bier, also in Europe. And you can see a photo of the river. It was taken close to its origin near the outflow of Lake Teletskoye, that you can see on the poster. And the assumption that I'm working with is that the Bier River generally has the potential to freely develop its river course. And one first step in my work was to determine the channel sinuosity based on the river network that had been generated from a digital elevation model of a 30-meter cell size resolution. And this sinuosity index basically quantifies the channel's deviation from a straight course. And it was calculated for substretches of 5 kilometer length using the ArcGIS software. And the same was done for reasons of like to have first comparison for an Austrian river, namely the Traun River, in both a historic and current situation. And you can see the results for that on the box plot graph. It shows that the ranges of the sinuosity values are comparable, and they are in the range of what is usually called a sinuous river. What you can see here is that the median value of the Traun River at its historical situation is slightly higher than that in its current situation on the left side. And it's also more similar to the values that were achieved from the data from the Bier River in Russia, which is perfectly in line with the expectations that I had initially. Since the data from the Bier River shows a higher variability than the more impacted site at the Traun River. And this is not at all surprising, and it's nicely, it's nice that those preliminary results show that the initial assumptions are not totally off. And the further steps will be to set these parameters into a relation with other topographic parameters like slope and also with land cover of the surrounding areas. Another point will be to establish an overview of pebble count data, which has been derived by a students team that was on site last summer. And based on this information, similar stretches will then be identified for a closer comparison. And the hope is that this systematic characterization will support process understanding regarding the connection between topographic parameters and channel form. And it will hopefully provide an orientation for designing restoration goals also here in Europe. Well, thank you. That's basically what I wanted to tell you today.
Thank you. Yeah, that's, and I encourage people to just go look on Google Earth. This river is amazing. I have some screenshots to some friends. It was like, whoa, this is quite something. Okay, well, thank you for your presentation. It'd be good to have some discussion about it. So the next presentation is by Thais Yamakasi, and it's about estimating the resistance of a porous media that numerically represents a floating wetland. I started my research on wetlands, and I think it's really important in your career to like work across both wetlands and rivers. So I'm interested to learn some more about wetlands.
Hi, hello. Good morning from Brazil. Thanks for having me. So I'll share my screen. Okay, hello everyone. Thanks for having me. My presentation is about the numerical representation of floating treatment wetlands. Basically, floating treatment wetlands are an alternative to treat water, wastewater, and stormwater by using floating plants as the main driver of the treatment. In this case, the reactive part that is responsible for the treatment is the plant's root zone, because the roots are in constant contact with the water. So in a CFD model, we are interested in defining the root zone. In this work, I propose to represent the root zone as a porous media, using the packed bed approach to define the resistance exerted by the roots. To do so, we need to calculate two coefficients, 1 over alpha, which is the viscous resistance, and C2, which is the inertial resistance. They are both dependent on the characteristic diameter, which is dP, and the void fraction, which is epsilon. Also, instead of assuming isotropic resistance, we can do the following. In the horizontal direction, where the flow is perpendicular to the roots, we can assume dP as the root cylinder diameter. But in the vertical direction, where the flow is parallel to the roots, we can assume dP as being the hydraulic diameter, dH, which depends on the root cylinder diameter, but also on the spacing between the roots. So I tested this approach for a lab scale floating wetland, and I compared it with the more straightforward way of just fitting the resistance to the measurements. And here are the results. In figure 1, I plotted the longitudinal hue velocity profile passing through a floating wetland. The wetland is located between 0 and 1 in the x-axis. In this case, both approaches, the calculated and the fitted resistances, resulted in similar curves, and both curves were well adjusted to the measurements, which is great. The difference was observed when I put 4 floating wetlands in series and plotted the flow just upstream of each wetland, as given in figure 2. In this case, the calculated resistance given by the open squares was more precise than the fitted resistance given by the open triangles, especially for the last 2 wetlands. So from these simulations, I conclude that the porous media combined with the non-isotropic resistance is a potential reliable method to represent the root zone in CFD. Thank you very much.
All
Okay.
right, thank you. So
So
where
I-
are we here?
I think we're
Return?
now going to the next presentation. So, hi everyone, my name is Rosé Casas Munet from TUM Munich, and I will be presenting the next 4 talks briefly. From so far, from what we get, I'm really already looking forward to the discussion afterwards. So, let's go to our next speaker, Ana Carolina Valencia, and she's going to talk about the word hydro environment, its origins, and the use of it. So, Ana Carolina, the floor is yours.
Hi. Good morning, everybody. Thank you so much for having me. I'm Ana Carolina from Panama City, Panama. I will be more than glad to show you my presentation about the origins of hydro environment. Okay, just let me know if you can see my presentation, okay?
Yep, we can see it.
Okay. Yeah, okay, thank you so much. Well, first of all, I would like to introduce why I choose the research. Well, first of all, this is a new concept. The hydro environment actually is not even on a dictionary. So what I wanted to search or maybe prove that actually there is there's always a changing on the sciences, on the concepts that we use on our sciences. So most of the common topics today are environmental problems. Well, people should not forget about the importance of them for our environmental, the elements, the conditions, and the influences of our surrounding. So I think that hydroenvironment concepts responds to today's issues, which involves all the matters about our environment. This concept actually was first introduced in the IAHR World Congress at Vancouver in 2009. So this is one of the first examples of how that today's problems actually may change on how we use the words and how we use the definitions of what we commonly use. And other things to point out is actually that nowadays there are no such methods developed in order to respond to these new trends, or maybe guidelines or specific guidelines under this new term of under hydroenvironment. Although it had been around for a few years since the scientific has been using it, because it involves new trends of the sciences that we normally use as hydrology, hydromantic. So these trends, I think that maybe it's good to highlight the importance of following new modern trends in the care of environment. So in this specific case, the hydroenvironment. Another example is that this trend leads to develop the new sciences and the new concepts, as I mentioned before, as an example of hydrology. I found a very important and very curious guideline on the UNESCO in 2004 about the eco-hydrology in problem solving. I think that you can search it. You can see on the bottom of this, my poster. This is like a guideline of how the both part, the eco and the hydrology could merge together and we can solve problems with them. So just as a conclusion for you, I think that maybe we should learn to be more open to new definitions, and actually we should learn from the work systems pandemic situation that we have right now to try to new things to encourage the research and the studies to anticipate the problems that we'll be facing in the future and try to figure out the ones that we already have. So either if you have any other further questions or any comments, I'm free to answer to you after the coffee break. This is all for now. Thank you so much for your attention.
Thank you very much, Ana Carolina. Yeah, definitely we'll have discussions on this matter. We now going to go to Joana Herrera, and she's going to talk about phytoremediation of contaminated soils. We go into terrestrial environments. So Joana, the floor is yours.
Good morning, everybody. I am Claudia Medina. I am talking about this research paper instead of my partner, Joana. So I will share my screen. Okay. Well, greetings from Bolivia to everybody. I will begin my presentation by telling you the context of Milluni. Geographically, Milluni is located at the beginning of the Qatari Basin, between the Andes Mountains and the cities of La Paz and El Alto. It contains a water reservoir which provides fresh water to part of the population of the mentioned cities. So intense mining activities have been carried out in the Milluni area during the 20th century, causing living environmental passives, unattended environmental passives, and causing the pollution of the surrounding soil and some water bodies of the zone through the runoff of the acid mine drainage. So as environmental engineering students, my team and I focused on the soil pollution with heavy metals through the assessment of the employment of Vertesimal Berkinata and Lupinus balanus as plateau native species in the soil phytoremediation technique for this area. So how did we do it? We took soil samples from the study area, then we mixed the polluted soil with potting soil in order to distribute the samples into 4 pots. because 2 of them were free of polluted soil in order to have them of control as a control pots. So we tested 3 plants from each species, 3 Fortesimalvas and 3 Lupinus, by planting them into the pots and keeping them in greenhouse conditions during the study period. So we performed control tests once a week, in which we measured pH, temperature, and conductivity from the soil of each pot. At the end of the study period, we observed the presence or absence of chloroplasts in the leaves. And we obtained percentage differences of pH and conductivity measurements in order to analyze the evolution of the soil status over time. Finally, we performed an analysis of variance to detect 3 sources of variability: the species of plants with 6 different concentrations of polluted soil, the time, and random error. So we obtained the following results. We detected statistical differences among the treatments, and as you can see on the figure 1, a pH increment with a maximum value of 53.2 for Lupinus species, and a conductivity reduction, which maximum value was obtained for the Fortesimalva with 61.14. Then we obtained that during the microscopic observation of the chloroplast, Fortesimalva didn't present any sign of the chlorosis effect. Finally, Lupinus Balianus showed a periodic decay until the end of the study period. So through the analysis of these results, we obtained the following conclusions. Fortesimalva echinata can be considered as a phytoremediation plant due to the absence of the toxicologic effects during the study period. Then Lupinus Balianus employment can be discarded because during the study period it showed a periodic decay which may be attributed to the toxicological effect of the heavy metals on the system plant. And finally, we recommend that this study should be performed in the environmental conditions of Miljuni Valley to obtain a better assessment of the phytoremediation effectiveness. Well, thank you very much. That's everything for that.
Okay, thank you very much, Claudia. Sorry, I missed the change of presenters. We'll have a discussion later. And now we're gonna go to Carlos Julio Hernandez, who's gonna tell us about the ecohydraulic impacts of plastic flow on the Magdalena River. Julio, go ahead.
Okay, thank you. Thank you very much for introducing me. I will share my screen. Can you all see my presentation? Okay, thank you very much.
Yeah.
Okay, good morning, estimated audience. My name is Carlos Hernandez. Both the co-authors, Joana Serra, Gerson Rodriguez, and me, we all make part of the Fundación Universidad Norte, YPN from Barranquilla, Colombia. The day of today, I present our results concerning the topic eco-hydraulic impact of plastic flow for the mouth of the Magdalena River and adjacent beaches. The Magdalena River is a principal river in Colombia, and it is top 5 among the most important waterways in South America. It is also one of the most polluted water courses worldwide. In 2017, Lebreton et al. Ranked the Magdalena River as 15th worst waterway that discharges higher amount of plastics into the ocean. This work, our work, has identified a possible indirect method to determine the volume of plastic that reaches the Caribbean Sea from the lower Magdalena. I will describe in more detail the process that we have followed and then compare our results with those obtained by Lebreton et al. Our analysis focused mainly on in situ data from different cleaning events near the mouth of the river, but it stands out the data obtained from a garbage island whose location you can see here in figure 1. This debris path was located near the shoreline 17 kilometers from the mouth of the river, the Magdalena River. Here in figure 2, you can distinguish how this island of garbage looked like. Most of these debris corresponded to wood, but it was also found that approximately 20% of these debris corresponded also to plastics. On the other hand, from satellite images as well as drone videos, it was possible for us to estimate the area covered by this island of garbage. We use QGIS as a tool to reveal the shape and size of this island of garbage. Via these sources, we also could determine the period in which this island of garbage was formed. This island was formed in a period of 2 to 4 days, 3 days midpoint. Then, by using an overall low-density polyethylene of 940 kilograms per cubic meter, we could calculate the approximate daily mass input of plastics that entered the island during this interval, I mean 3 days midpoint. By making all these operations, we obtain a final result of 65 tons of garbage of plastics per day. These results are pretty important since an overall projection of these rates led us to a result of 2.37 times 10 raised to the power of 4 tons per year, which is quite close to the upper mass input of 2.95 times 10 raised to the power of 4 tons per year, estimated by Clevereto et al. For the lower Magdalena. This overview indicates us that our result is within the range estimated by these authors. Our conclusions. Okay, in conclusion, the data review in this research confirmed the incidence of this eco-hydraulic problem of plastic flow within the Magdalena River. On the other hand, our results also suggest that garbage patches volumes may be used as a proxy information to estimate the plastic mass inputs for the lower Magdalena. This is definitely important in the future in order to highlight the need of a plastic management plan in our region, and also in order to avoid these problems that significantly affects both the biota and the community welfare of our region. Thank you very much for your attention.
Thank you very much, Carlos Julio, to give us this link of aquatic freshwater to marine systems. We're going to go now to Arianna Varrani, who's also going to go into plastics, but specifically in streams, and she's going to talk about transport dynamics and open questions. So Arianna, please, the floor is yours.
Okay, let's see. Okay, do you see everything fine and do you hear everything?
Yep.
Okay, perfect. Thanks for having me here. I am Arianna Varrani. I work at the Institute of Geophysics at the Polish Academy of Sciences, and I will continue a bit on the plastic thread. Okay, my poster deals with plastic in streams, and the title is Plastic in Streams, Transport Dynamics and Open Questions. I will start with the open questions. Well, I think it's now clear that low-tech environments act mostly as pathways for plastic debris from their source, their sink. And one of the main assumptions is that plastic in rivers move as either sediments, so either as suspended and wash load or as bed load. The main aim behind this poster was to study those heavier plastics, so those that are able to deposit for a while on the river bed. And we wanted to, let's say, model, we wanted to see when these plastics start to move. So we carried out experiments at the Mountain Hydraulics Laboratory of Politecnico di Milano in Lecco, and the results are shown in figure 1. The only data that we decided to measure were the discharges, the water depth, And we decided to record the the bed movements with a camera from the top of the water. And from the only two flow variables, we estimated the mean bed shear stress with these formulas. And for the sediment discharge, we estimated it from the data retrieved from the camera. And here in the figure, I show you with the blue bars, the sediment discharge, and with the red diamonds, the ratio between the mean bed shear stress and the critical one. The critical value for the bed shear stress was chosen actually arbitrarily. We decided that we were at the very beginning of the transition between laminar and turbulent flow, and we decided that we were practically laying on the interpolated Shields curve. These results are in line with previous results with similar sediments and with bed load carried on in a similar flume, and let's say match the only other study I found on the erosion behavior of microplastics. So we were kind of not totally satisfied, because for the estimate of the mean bed shear stress, it was really rough, but we were kind of happy with that. To conclude, we will carry out a more, let's say, detailed experiments in our lab here. And the idea is to improve the estimate of the mean bed shear stresses, having a velocity profile over a vertical. And yeah, that's more or less all what I wanted to tell you today. I hope it was interesting. If you have questions, I'll stay online. Thanks.
It was definitely very interesting. Thanks, Ariana. And I think with this, I conclude, and I'll pass the word to our third chair, Go.
Hi, thank you, Rosa. Greetings from Malaysia. I'm Go from River Engineering and Urban Drainage Management. I'll be the chair for the last 3 papers of this session, and we will follow up by the Q&A sessions. So you're welcome to type your questions in under the Q&A. Without further ado, let me introduce our next presenter, Lucas Ziborowski from Institute of Geophysics, Polish Academy of Science, Poland.
Yeah.
Lucas, the floor is yours.
Thank you very much. Can you hear me? So I will share my screen. Okay.
Okay, perfect.
So one more time, good afternoon. I want to show you on behalf of our small research team dealing with the vegetation in aquatic environment. I would like to show you our recent study. Based on the measurements that we conducted in the lowland natural river in Poland, we took a close view on the velocity fluctuation statistics downstream of flexible submerged aquatic plants. In the first figure, you can see the setup that we had in the river with 2 different plant species. The plant patches had this elongated shape, and the grid of dots represents here velocity measurements points downstream of the plants. And there were flexible plants. That is very important. And there were 2 main aims for use of this data that we collect. First aim was to test modified conditional quadrant analysis for identification of coherent events. And the second aim was to find out if we could observe bursting phenomena downstream these patches. From theoretical point of view, in an abstracted flow, vortices randomly appear where there is sufficiently high shear stress, and so they typically originate from the bottom boundary layer, where the bottom roughness creates shear. In our case, the vegetation adds additional shear, so we expect changes in events distribution throughout the water depth profile. We used thresholding in the quadrant analysis, so we could focus on the coherent events representing the highest stress levels to avoid the noise of the smaller velocity fluctuations. Now please take a look at the second picture. The stripes represent the time-averaged stress contribution of each of the 4 types of events, and the background shows the interpolated field of time-averaged Reynolds stress. Points on the left side are closest to the patch, and the blue line here is an average height of the patch. As you can see, below that line, there are sweeps shown here in the yellow color. Those sweeps are the streaks of the higher velocity directing downwards. Sweeps there were more frequent and longer, which we derive from the time characteristics, and contributed much more to the time-averaged Reynolds stress than any other event in this area downstream the plants. The second strongest type of coherent events, the ejections which are marked here as the blue stripes, dominated above the vegetation height. This divergence suggests that the hairpin vortices were forming above the plants and that they were dissolving further downstream, which caused those changes in events characteristics that we observed. In other words, a mixing layer forming at the boundary of the plant patch and the free flow above is the place where the vertically oriented vortices forms, and they are carried downstream. The changes in velocity fluctuation caused by their passage are visible in our results as downward-oriented sweeps and upward-oriented ejections. That is just the part of the whole analysis we made, but probably the most important, and that is what I wanted to show you today. I would also like to tell you that in the future we would like to check if we can correlate the frequency of plant motions with the occurrences of the extreme coherent events. That's all. Thank you for your attention, and feel free to ask questions in the chat.
Thank you, Lucas, for your wonderful presentation. Now, let's move on to the next speaker. She is Stephanie Muller from University of Manchester, United Kingdom. Is Stephanie here? She will be presenting about a study related to the fish swimming behavior. Stephanie, the floor is yours.
Sorry, just some technical issues here. I hope you can see my screen and hear me.
Yes, perfect.
Wonderful. Well, greetings from the UK. My name is Stephanie. I'm from Cardiff University. And yeah, I would like to tell you a bit more about our ongoing work on vertical axis river turbines and their impact on fish behavior. So this research was conducted with the background that we've got and constantly increasing global energy demand. So there's an urgent need to find more renewable energy technologies with low environmental impact. And hydrokinetic vertical axis turbines may present one opportunity, as these turbines do not need a hydraulic structure, so we won't need a dam or a weir, and they can operate in shallow waters and low to medium flows, which are typically found in rivers and estuaries. However, so far, little is known about their impact on hydrodynamics and particularly on fish behavior. Now, to better understand how the wake of a vertical axis turbine impacts fish swimming kinematics and their spatial preference, we are currently conducting some small-scale experiments in our hydraulic facilities and our flume facilities with a single vertical axis turbine and some juvenile rainbow trouts. Now, wake hydrodynamics have been measured using acoustic Doppler velocimetry for 9 cross-sections downstream of a single vertical axis turbines, and fish behavior was recorded using a camera which was mounted above the flume, so it gave us the opportunity to have a view of the test section from above. And the results were then analyzed using an open source software called Sensory Orientation, software, which we adapted a little bit, and it gave us the opportunity to track an individual fish within the entire test section, so upstream and downstream, and to monitor their spatial preference as well as the swimming kinematics, like tail beat frequency, for example. Now, this is ongoing work in progress. So the results shown here are only preliminary results from a few tests we've run so far. But looking at the hydrodynamics, which are shown in figure 3 as cross-section control plots, showing the normalized streamwise mean velocities for our 9 cross-sections measured downstream for different spacing from the turbine, you can see that immediately downstream of the turbine, we've got a low momentum region, which is asymmetrical about the center line. So it's shifted towards the upstroke side. So in our case, our turbine is rotating in counterclockwise direction. And on either side of the turbine, you can see some high momentum regions, which are indicated by these yellow-greenish areas. Now, from the few fish we've tested so far, we could see that most of them prefer to stay inside the wake, so in the low velocity region downstream of the turbine. But despite these high velocities on either side of the turbine, they still moved from the downstream section into the upstream section. Now, using these motion tracking algorithms is going to give us the opportunity to get some insights into like the behavior adaptations of fish to changes of flow of wakes, for example. And we can see like the changes in swimming kinematics, their preferences of the spatial usage, their potential attraction or avoidance behavior. And with this knowledge, we hope to be able to improve like turbine arrangements for their operation and design. Now, as mentioned, this is ongoing work and hopefully will be completed over the next weeks. I want to give you a quick idea of what we are planning. So we're aiming to test 2 different discharges to see whether fish tend to seek refuge in the wakes if the velocities increase, the bulk velocity increases. And we want to see how small groups of fish, for example, respond to multiple turbines. So in our case, to a twin turbine setup. I also have a look on the issue of confinement, because our flume facilities are quite small. So we want to compare it to a turbine in a wider flume. Yeah, that's from my side. I'm looking forward to the discussion. Thank you very much.
Thank you, Stephanie. Now, let's move on to the last presenter for today's session, Cui Han Wen from University of New South Wales, Canberra. The title of the presentation is Velocity Profiles on a Grassline Spillway in Supercritical Flow. Cui, are you ready?
Yes, thank you. All right. Can you see my screen right now?
Yes.
All right, good. Awesome. So my research would be the velocity profiles of the grass channel on a supercritical flow condition. So grass spillways represent an overall eco-friendly solution for the renovation of hydraulic structures, such as in agricultural waterways, grass embankment, and urban drainage system. So the grass spillway basically just supports the local ecosystem, and well, but doing that, meanwhile, it also can reduce the carbon footprint while we're building these hydraulic structures. The velocity profiles of the grass spillways are of great importance in the regulation of the flow resistance and the boundary layer properties of these type of flows. In the past, there is only a limited number of studies into the velocity profiles of glass channel in a supercritical flow condition, where the supercritical flow condition generally features the self-aeration and the free surface fluctuations, as shown as figure 1 here. That's in 150 liter per second discharge, 125 liter per second in the laboratory scale. And well, on the contrary, the velocity profiles of subcritical flow condition, which generally exhibit smooth and calm flow behavior, have been extensively investigated. And the velocity profiles was decomposed in 5 layers in very great details, as shown by Nicholas et al. In 2013. So herein, the systematic experiments have been conducted in the water research laboratory at the University of New South Wales to obtain velocity profiles in the supercritical flow conditions. The velocity profiles was measured by a pedal tube and over a mildly sloped channel equipped with a dense coverage of the glass. Together, by the way, the glass is is mimicked by the artificial turf that we obtained from the manufacturer, and together with the conductivity probe, aeration property have been documented around the channel as well in 8 locations with 1 meter interval for flow rates, for 4 flow rates represented by a fruit number from 1.46 to 3.42, which puts us at in the supercritical flow definition. So as figure 2 shows, the velocity profiles were successfully measured to demonstrate the development of the turbulent boundary layer from, as you can see, from x equals to 0.5 to x equals to 2.5, approaching to the uniform flow condition in the downstream end, where the velocity profiles are self-similar, as you can see, from x equal to 5.5 to x equal to 7.5, which reveals the uniform condition of the flow. The self-aeration of the flow over the glass channel, as indicated by the bubble count rate F and the void fraction C, is mainly concentrated in the upper layer of the flow near the free surface. Therefore, it supports the applicability of the pedal tube measurement in the lower part of the flow, while the air entrainment is negligible, such as, well, the very important log-law layer of the velocity profile decomposition. So basically, overall, the pedal tube measurement illustrated the distinct features such as the mixing layer of the flow, the inflection point of the velocity profile, the log-law layer, and the wake function region near the free surface. It uncovers a similar velocity decomposition as in the subcritical flow that proposed by Nicholas et al. So the velocity profile fit into this semi-analytical model of Nicholas et al. Is shown in figure 3. The fitting of the data demonstrates a close agreement, especially in the very important log-law layer. So the fitting from the measured velocity profile to the calculated one, especially in the log-law layer, would basically enable the fitting. It would enable the extraction of the shear velocity at the top of the glass canopy, which would, provide the very deep insights into the flow resistance of the glass channel, from in perspective of the point flow resistance. And the future application of this model is of great relevance, I think, to allow the further investigation of the performance of the glass spillway. And basically, that's the end of my presentation. And thanks for having me here.
Thank you, Cui. So that's end our presentation for this session. Now let's move on to the coffee break session, whereby we are open to the Q&A, and we will 3 of us will take turn to ask questions that is being typed in the Q&A. So Greg, do you want to start first?
So I think actually we're going to have Roser start with just a little bit of a mention about the EcoENet community.
Sure. Thanks for putting me on the spot, Greg. That's great. No, okay. Well, thanks everyone for being in this exciting session. I see that there's quite a high participation, so that's very exciting. I think, well, what I have to say, I am the current chair of the Early Career Network research on ecohydraulics, and I'm very happy to be participating in this. Sorry, my phone just went off. In this session, because it's a great initiative to basically engage early careers and mentors, and I think this is the perfect platform to do so. So yeah, I just want to add also that the presentations are also providing a great range of topics that represent ecohydraulics, and it's very exciting to see all this interaction. I think it's just the start of a very good future for ecohydraulics. So yeah, that's all I wanted to say. I don't know if we should start by reading some of the Q&A questions. If you want to go ahead, Greg, or should I just start with some questions? What do you think?
Yeah. I mean, I can start with the first three presentations, and so I guess some of the questions have already been answered for Miriam. But Miriam, I also just wrote down some questions just about the for the experiments you were doing. So can you talk a little bit about like acclimate the fish when they're getting started, and then do you have several fish in the flume and are they sort of like competing to get into the slot, or how do you know how the role of behavior is affecting their passage through the slot?
Yeah, thank you very much for your question. This is really good question, because actually apart from fish entry through the slot entrance, we are trying to also monitor their behavior so at the moment we are trying to find two parameters. One is fish entry pattern, how they so to be consistent 10 seconds before each entry, we are trying to monitor how they entered and with which direction or some different kind of behavior. So we trying to use different codes for that. And also plus we are monitoring the fish entry height at each to see at each height they are tending to enter to the slotted entrance.
And there was a question that was asked about the kinds of fish that you're going to use. Like where do you get the fish? Are they wild? Like do you have to acclimate them, or do they go like more straight? From I've seen cases where people will just like collect wild fish and then use them same day, or they have a mobile laboratory. Well, your laboratory is not mobile, but yeah, how is that process of collection and
So they are hatchery juvenile silver perch. So we purchase them from an approved commercial fisheries, and yeah, I don't think so that they are wild, but it is really good to take into consideration to also bring wild fish to the laboratory and do some experiment, and even we can compare the results.
It certainly gives you a chance to get out to nature and go fishing, get some get some fish to put in there. Just, I mean, in general, like, what has your experience been like running a flume? I mean, have you felt that it's been exciting? Is it particularly challenging? Just talk about you personally running a flume.
Actually, I'm coming from water engineering background. So my master was in hydraulic structures, and in my master, I worked in a really long boundary channel, like 80 meters in length and 1.2 in width. So I had experience, and I find it quite interesting to work in open channel flume. Yeah.
And what is your career goal after your degree?
Sorry, I didn't get your question.
Sorry, my internet was. What is your career goal? Like once you get your degree, what do you want to do?
Actually, I have decided my future career. I want to start working in fisheries as a project engineer or some sort of things. I don't want to be to stay in academia and to be a faculty. Although life is not happening as always and as our will, but let's see what happens.
All right. Yeah. Well, if people have more questions for Miriam, just put them into the Q&A chat and we'll.
That would be great. There. Looking forward for that. Thank you very much.
Sure. Yeah. Well, okay. Well, let's move on to Lisa. So, Lisa, we've had some questions in the chat just asking more about the sinuosity. I mean, it seems like I think your river is pretty confined, like it's sort of canyon confined or partially confined. So maybe you could just talk a little bit more about the setting and what your expectations are for sinuosity and how it may or may not change as a result of human activity.
Do you mean within the Bier River or in general?
Yeah, no, I think specifically there, because showing the results, like the differences that you found in that river versus others, like, it doesn't seem like it's been straightened much, but it's also in a pretty valley confined or canyon confined, wouldn't you say?
Yes, that's true. The thing is that the whole area has been subject to glaciation in the past, and that might be a reason why there is this defined valley situation that the river is following. Is that the direction that you were going into? I'm not so sure about.
Well, so one of the driving question you're asking is whether you can use data from this remote river that's fairly naturalized to help figure out attributes for degraded rivers and more like urbanizing kinds of settings and stuff, right?
Yes, but the basic assumption is also that the rivers that are to be compared have to have a comparable geological background, like past glaciation within the area must be given in order to compare the two the two systems. So this is
like, what kind of attributes do you want to be able to take from that river to help inform river restoration in other places? I mean, assuming that the channel type and geology are consistent.
Yeah, the first thing that I looked at was the sinuosity within the river, and this, of course, will have to be related to slope within the stretches, and the more interesting part will actually, in my opinion, be width variations. To look at this parameter, because this is like a really relevant parameter that has been affected due to anthropogenic impacts in Central Europe. And if we assume that the Bier River still has the potential to develop its course and also its width as it would naturally, then this would be a valuable information how these variations change over the course of the river. Also, again, related to sinuosity within the stretch and slope in this particular stretch.
So are you using things like the API for Google Earth Engine or other, what kind of remote sensing tools are you using or developing so like you can extract width series and analyze them from different rivers?
I am not yet have not yet achieved one method that I'm totally confident with. The thing is that my approach should ideally focus on a master thesis that has already been completed by another student from a different university, because that's my supervisor's basically his idea was to go with the same approach as this other student. So I'm afraid I will not have so much freedom, and I'll have to use the land cover data that is available online. Yeah.
You just have to tell your advisor what you want to do.
That's also true. That might, yeah.
And I know your advisor, so I'm just teasing
current,
him too.
yeah, the current idea is to use the Landsat data, and yeah.
I mean, just I asked with the what is your experience when someone tells you here is how many tens of thousands square kilometer watershed that river is, and it's like, okay, go ahead and figure this out for us. Like, has that felt pretty daunting, or you're up for the challenge and it's been exciting?
So I did not catch most of the question because there were some technical issues. But
sorry, you're looking at such a large watershed. Yes. Have you found that daunting or exciting? Is it it's very challenging?
Yeah,
someone's just like, go to Brazil and tell me how the Amazon works.
Yeah, I think it is really a problem right now, especially due to the fact that at the moment it's difficult to have personal conversations with people and to just discuss issues that come up. That makes it even more difficult to deal with kind of like complex topics, like the whole reference situation approach. That's also, there's a lot of discussion that can be had about it, and yeah, I agree.
And what's your career goal after you get your degree?
Well, I'll have to see. I'm still looking.
All options are on the table.
Yes.
All options. Okay. Yeah. All right. Well, thanks. Again, if there's more questions, please put them into the Q&A. So let's move on to Thijs. Your experiments on floating treatment. So I think you addressed it already in the chat, but I was wondering, so, as you complete the parameterization effort, what kinds of numerical model runs do you plan to do to examine the floating treatment wetlands?
Well, we are doing simulations on varying the root length as if the roots are growing. So we want to know how they will affect the flow field and the treatment. But I think this simulations open to many possibilities. So I'm doing this, but we can work on, for instance, island arrangement, like floating wetland arrangement, how it will affect the treatment performance. We can tackle on sedimentation, how the roots will induce sedimentation coming from the untreated flow. We can see the biofilm, which is a slimy film that grows attached to the roots, and it enhances the treatment performance. And what if it increases the permeability? No, reduces the permeability of the roots. We can think of floating mats. What if we plant, for instance, 4 initial plants or versus 10 initial plants? Will it affect the permeability and thus the flow field? So there are many possibilities in regards to the wetlands, but conversely, we can think about the channel, the pond, the flow conditions as well. So for instance, is the inlet the whole cross-section of the channel that we are considering, or is the inlet a pipeline that is directing the untreated flow? How will the jet orientation affect the treatment performance? So it's all ultimately, all these studies are ultimately focused on improving the design of those floating treatment wetlands, I think.
And do you have a sense of what your career goal is?
Well, I really like vegetated flows, studying vegetated flows in any sense. I'm helping a friend of mine who's studying growing fields with vegetation. It's very nice. It's a totally different type of flow. But I'm very open. I think both the academic or the non-academic career is very interesting. I have this difficulty in defining a specific thing. I really like any challenge, any new things. Yeah.
Hi, Thais. I'm Go from Malaysia. Your topic is sounds very interesting to us because I am currently doing research on wetland, and just would like to share our previous experience. We have conducted one floating wetland competition between the secondary school students and university students by using the recyclable material. So just would like to ask you that in your study about this CFD on the root length and types, we are wondering what is your assumption for the type of roots that you define. What I mean is because there are many types of wetland plants being used.
Yeah,
so
that's true.
you define homogeneous type of roots, or you are doing the different types of roots?
Yeah, these simulations were validated with a lab scale floating wetland. And in this study that I used as the measurements, they assumed the roots as cylinders, rigid cylinders. And they validated the lab floating wetland based on, I think it's E. crassipes, the species of the plant. It is a very common floating plant, both here in South America, in North America, in Australia. So yeah, the vegetation is we assume a rigid cylinder array that composes the root zone.
So you are using single species. How about the material that is being used for the floating wetland simulation? The validation part, you do a real floating
it's
wetland.
single.
Right? So what kind of material that you use for that?
Yeah, it's a, well, for the simulations, we don't need to define the type of the flowing mat, although I know that from the several studies that I've read, they use coconut fiber or plastic bottles. There are many possibilities to create the mat, but in the simulations, we are not considering the possible impact of the floating mat on the flow field. We are considering just the root zone. And yeah, that's it.
Okay, I pass the floor back to Rosa.
I think now I'm just going to take a few questions for the next 4 talks. So thanks again, everyone. I'm going to start with Ana Carolina Valencia. Ana Carolina, thanks very much for your presentation on telling us about the emerging hydro environment concept. And we in the eco-hydrologists community are quite involved on this definition of concepts, because I think always behind a concept there's a community. So first, I have a couple of questions for you. First of all, how do you think this hydro environment concept differs to eco-hydrology and eco-hydrology, which you had also mentioned? And just, do you think it's about scale? It's about how do you think this concept will grow into community, for example, or how it differs from the existing communities, which are quite well established as eco-hydrology and eco-hydrology?
Hi. Well, I think that maybe one of the first things actually that as a new concept that have been adopted is not quite defined yet, but I think maybe in the future, or maybe how the time passes by, will be more clear about how this is going to what is this going to involve. For now, most of the people that use it is referring to what if trying to, well, they use it as their own, that they think they will be, they define what they want to show. That's what I think. So maybe in the future, the more that we use and the more that we start defining this, we can maybe make it one concept by itself, and actually it will be more defined in the future. But we must continue using it, and we must continue trying to make some research and actually trying to use this. Well, that's what I mean.
Thanks, Ana Carolina. That's an exciting place to be, I guess. Just to, if you can already kind of try to define where this is going to be by small actions. So, following Greg's questions on your goals in your career, how much do you think you're going to be interacting, or how much you're going to be working in hybrid environment in the future, and from which point of view?
Yeah, from my point of view, maybe I can make an example from my country. We are in Panama City, so we actually blessed, I can say, that we have the two oceans. We have Pacific and we have the Atlantic, and we do not have like that kind of hydro environment culture. I can say that maybe this is like the first steps for me for try to implement this in my country and try to bring that onto my country or my own community, scientific community. I think that maybe in the research that I have done, it's not a lot of people that have this knowledge of this concept here in my country. So actually referring to that hydro environment by itself, I think that maybe this is a good point of a start to try to impulse and involve this in my country and try to be more engaged with it.
Thank you very much.
Oh,
okay, I think the time is running, so I'm just going to go to Carlos Julio. Thanks for your presentation, and I think perhaps I'm just going to just directly tackle the question of the future, and also tackling both questions at the time. So basically, you said that this quantification will lead to helping support future plans of the management of plastic. So it seems that obviously this is not in place in this area. And do you see yourself helping in this regard in the future? Do you see yourself as doing some research on this, or just go into the practice and help tackle this real issue?
Okay, in my case, I have not finished yet my bachelor, but I would, with pleasure, contribute to my city in this topic. I think that there's much to do in my city regarding this topic, and I think that I could contribute in the solution of this issue. Yeah.
Thank you very much. That's very exciting. Okay, and just because we have to go on, I think perhaps if we finish on time, we can still go back to some additional questions to individuals. I'm now going to go to Arianna, and I just have a specific question on the cameras that you said that you are planning to use additional cameras in the future, but you also applied some cameras now. Yeah. Is that right in that test? And the second question is whether you found that shear stress is a good indicator for your assessment. So there's two questions here on one.
Okay, we use GoPro cameras, GoPro 4, GoPro 4 Plus. And if I get funded, we get better cameras. We'll see, I'm waiting. So the first question. The second question, I'm not sure that bed shear stresses are the best indicator, because it's a very low, the idea was to observe incipient motion of single particles. So it's a very local, let's say, process. But in rivers, you'll never see that much, let's say, you never have so detailed, I think, so detailed information about those small scale local quantities. So it was just a trial approach, like, what do I have? I have the discharge, I have the level, let's try. If it makes sense, I'm happy. If it doesn't, well, I need to work harder. But I mean, as a first try, I think it starts making sense. It doesn't make sense yet. But I would not know which other quantities to use, if not the batch shear stress. So.
Okay, that's perhaps an open question for the audience, so perhaps they can give you some tips on which way to go. I just following up the question on the future, you said that you are waiting or applying for funding. In that sense, how much involved you are in your funding application? Like, is it for your PhD or is it funding for post PhD? What would be that funding for?
That funding, I am a principal investigator on a project for my PhD, to do for my PhD. And if I don't get it, I don't know. We'll see.
Uncertainty.
Yeah, well, it's best year, no? Best year for that.
No, but it's good that you raised this, because I think this is something that probably everyone here is facing right now or has been faced in some stage on their career. So it's good to raise this up as well. So it's quite exciting that you're already writing proposal and you can be the principal investigator in it. So I think it's very good. I think that's the end for my questions. So thanks, Ariana, and thanks everyone else. And I think now I'll pass the word to Go, so we can finish on the last.
Okay, let me check on the question and answer box. I think most of the questions has been answered by the presenters. For today's session, actually, we are open as chair. We are open for the questions from you guys. Besides, we ask the questions. So, anyone else would like to ask anything? If no, then I will ask about. There are a lot of interesting discussion about the fish today, and for Stephanie, there has been a question for the previous presenter asked about which will different types of fish show different behavior. So because your study is about the fish swimming behavior, you are using the trout, right? So what do you think if we use different type of fish, will it affect the results of your experiment?
Definitely. I mean, it was a question in the question and answer panel about using bottom feeding fish and less strong fish. And definitely think there is an impact, because I would assume like less strong fish would probably be more attracted to the wakes or to the low velocity areas. And it would definitely be interesting to test, because trout are quite strong swimmers, so probably might not be too challenging for them.
Just wonder how you enter this area to do research on the fish.
Interest, I see. Yeah, during my master's, I was involved in a project about fish-friendly hydropower plants. I was doing the modeling part, and now I got a chance to do the experiments and to actually work with the fish, which is really nice. I learned a lot from just watching them, how they behave.
Okay, I think it's a very good cross section, because previously the studies on the modeling is just based on the modeling, and right now there is a lot of interdiscipline cross that everybody can share their experience. So I think that's almost the time already. I'll pass the floor back to Jose. Hi, Jose. Yeah.
Just a second. I also realized that I had a question for Claudia, and I just skipped it. So I apologize for that. I think it's still. I think we might have. So Jose, perhaps you can just
Yeah.
tell us if we have a few more minutes to...
Just a minute. Right now, in few minutes, in 2 or 3 minutes, we are going to start the final session in fluid mechanics. If you want to continue in this room, as this is the final session in this room, in room number 2, you can continue, because I think that it is interesting that you continue giving the feedback to the authors. And I think that is a quite interesting chat that we have right now here. So
that's great.
Feel free to maintain the room.
That sounds great. So perhaps I can just ask a question to Claudia, and then we can continue, just have a full round of all the participants, and then we can open it to obviously interactions both ways. So Claudia, when I read your abstract, I realized I had to look for these plants because I'm not an expert in plants. But if I'm not wrong, they both terrestrial plants. Is that right? And I wanted to ask you if you could expand a bit more on what you think would be the links with aquatic systems, like your findings, how would affect aquatic systems, because I think it's a very important topic to understand better these terrestrial aquatic interlinks. So perhaps just you can expand a bit more on how it would be more linked to aquatic systems.
Okay. Well, these plants that we used were hyper-accumulative. So the roots can, absorb the heavy metals from the soil. And, Milioni is an ecosystem. It's an environmental system. So there is also the link between the soil and the water. I'm not sure if I can show you a picture because in the poster wasn't there the system. So just real quick, this is the water reservoir of Milioni. And as you can see, there is the soil with an orange color. So there you can see the presence of heavy metals in the soil and in the water. So there is this dynamic of the trespassing of heavy metals between both of the compartments. So we realized that this problem should be addressed as a system, as an everything, not just focusing on the water, not just focusing on the soil. So we realized that these plants can be, as they absorb the heavy metals from the soil and the water as well, we can apply them to just as a mitigation measure, So,
yeah, that's. I think this photo helps much better see the whole picture, and I think it's very, very important that you also mentioned this link. So it's great. Thank you very much. And perhaps just in terms of career goals, perhaps we can also ask you about what is your aim, like your career goal, what you're aiming to do in the next few years.
Well, right now I recently graduated from environmental engineering. So I want to do a master's degree in water resources management with adaptation to climate change, because I think it's really important. And here in Bolivia, we don't have that strong planification on this issue. So I think I can help my country to get a better, vision of it.
That's great, thanks. Okay, perhaps you can keep going with the next speaker, so we finish the round.
Yes, we finished the round. Let's see, anybody has any question for other speakers, or you have anything to discuss?
I had a question for Stephanie Mueller. I'm not a fish person per se, but I had some really interesting experiences to watch fish in some bypass channels, and I noticed that these juvenile fish had a tendency to quickly get themselves like trapped in a place that was like locally good enough, so they were like hanging out there, But, you could see, gee, fish, hey, if you knew about that place over there, you'd rather be much happier over there. It's like, I was just thinking from your experiments, do you find that fish get trapped into sort of like their little patch, and then, they're in that turbulent zone by the turbine that you have, but then like maybe they're still consuming a fair amount of energy. Is it better to find a way to encourage them to leave and go seek a better place or something?
It's an interesting point, because I'm personally a bit worried that if they actually get attracted to the wake, they would stay in the wake. Because there were studies, I think in the ocean, where fish accumulated behind hydraulic structures, behind turbines, and then got eaten by bigger mammals or other fish, which would be not ideal. I think the only way is probably test a huge number of fish to get like a broad view. In some other experiments, we had the case that fish just sat in the corner for the entire time.
Yeah.
Didn't want to move.
Right. Yeah. I mean, especially when you have like rectangular shapes, and suddenly corners become very attractive. I wonder if you could try something like, by varying the flow rate or like the operations, you could provide bursts every now and then that force them to like, relocate or like push them out. And so they have to then like reposition themselves or something, or maybe they just keep coming back to the same spots, but maybe then there's just not enough diversity of options for them to choose,
That's definitely interesting. Yeah. In one experiment, we tried to have some human interaction, like to get them out of the corner, but I have the feeling like if you interact with them, you kind of manipulate their behavior. So I'm a bit torn apart about it, leaving them in the corner or trying to get them explore. It's interesting, but difficult.
Yeah, I mean, I encourage you to make lots and lots of videos. Like, video is just so useful for taking a look at their behavior and trying things.
Can I ask something? Sometimes I have the feeling that small-scale lab experiments are probably not assumed as valuable as like fieldwork. So I was wondering what your point of view is on like fieldwork versus lab work.
I think that whatever somebody is doing, it's easy to get so entrenched in your way of looking at it, because it takes so much work, like to write one article, it just takes so much work. So you get so zeroed in on your way of looking at the world. That can be a problem no matter what you're doing. It's not, like I read one paper just this past week where they said that, field experiments is not controlled or not as good as flume experiment. But in that study, the flume experiment, they didn't actually use a scientific design. They just described the story of the flume. So it's when somebody asks you, what's the experiment of your flume? It's not just, oh, I had this size flume. It's like, how did I ask a question? How did I turn that into a hypothesis? What were my test metrics? The outcomes, and which of those outcomes the metric showed was right. So, I think that whether it's numerical modeling, remote sensing, field flume, you always have to find a way to put it into that scientific. And then over the arc of your career, in your PhD, you're very focused on one of those, but then it's really important other jobs where you get experience in other things.
I would like to add something to it as well. I think in general, obviously, if you're doing flume experiments, you think, oh, I should be doing field experiments. If you're doing field experiments, you're thinking I should be also testing this in a lab. So there's always a trade-off. And I think you kind of have answers at different levels. So when you want to have a very mechanistic understanding of processes and what's happening in this situation, it's a flume experiment can give you this. Then obviously you can extrapolate to field. But if you go to the field and you present these results, you can say, well, there's many other factors that can influence that, right? So obviously in an ideal world, you want to combine both. and that's great, but obviously resources and time are limited. So I think you just need to focus the question on what you want to answer, and just put forward that this is the best way that you have at the moment to answer these questions, and obviously be realistic about what you can answer with a flume or what you can answer with a field. That would be my view to it.
Thank you.
Perhaps I can add 1 or 2 sentences more. Just that for our undergraduate studies, we are going for broad. So we everything we learn a little bit, but when we when we proceed to the PhD studies, we are going into very deep. So in the lab scale studies, basically it is to set up the base for the detail of the study, so that you have no problem when you go for pilot and real field study. So that's all for me.
I just would like to make sure that we give the opportunity to everyone to have a say. So I just would like to focus the next question to, is Lucas still here? Yeah, to Lucas, and then perhaps to Han-Wen, and perhaps I will go straight to the future goals, like so obviously you very focused flume experiments. Are they part of your master? Are they part of your PhD? And where do you think you're going next? Perhaps following on this field lab, are you planning to do any field experiments to complement these very detailed flume experiments, Lucas?
In fact, those experiments were in the field, and
Sorry.
it was in the field, in the real river. So the whole toughness of this research was to find out if we can read anything from the results when we have open channel flow, unobstructed flow, if we don't account to the vegetation itself. Yeah? But we have large coherent structures going through the whole depth of the water, and they can, of course, give noise and ambient fluctuations of some bigger frequency, or rather lower frequency on our results. So going to the flume would give us much more probable, much more, we could be sure about the results, that what we are seeing is actually the effect of the vegetation. But to get the vegetation in the flume, that's not not an easy task. So I was thinking about going into the flume, but right now maybe I will focus with my friends in the institute on going more to the field and taking more repetitions. Of course, it will never be the same conditions, even in the same spot, even in the same time of the year, but then making more and more experiments, and then averaging more, the results can give the wider perspective of what's going on.
I agree. I think the more data you collect, it's the same environment, it's going to be different conditions, but I think it is still very valuable. And apologies, because I think I mixed the last couple of presentations. I thought that you were the one with the flume and Han-Wen the field. It was the opposite. But yeah, I think it's good. This is what you have, and I think it's great that you focus on your environment, and you're still gonna have a lot of valuable data from that. So thanks. And I think perhaps now I should pose the same question to Han-Wen, who work in the flumes. Can you please confirm? But I think yes, I can see.
Yeah.
Thank you.
No problem.
Okay, thank you, everybody. I think that it has been a really interesting session with a lot of participation, with a lot of activity and feedback. Thank you from everybody, the participants, our three special chairs, Greg, Ho, and Roser. It was a really pleasure to hear your advice, your piece of advice. And thank you all the participants for your incredible paper, your poster. It was a really interesting topic. And right now we have the final session related to fluid mechanics. It is in the room number 1. So if you are interested, I think it's also a really interesting topic. You can move there. We wait to enjoy the rest of the Congress. See you.
Thanks, Sia.
Very much.
Thank you.
I guess we're going to be disconnected, but sorry, Hanwen, that we did not get the chance to ask you the question. Like,
yeah, that's sure. That's why I'm not very sure whether to leave the room or not. Yeah, just in case you have like more questions regarding.
Yeah, just so you're planning to do field work, because I think it would be also very challenging, right?
Yeah. I mean, it could be an option in the future because like currently I'm in the first stage of the experiment, which use the artificial turf to simulate a very controlled and stable environment to like address some like the very fundamental problems in the flow resistance discussion. But well, obviously like what we are finding in the first stage, as I answered like Bill in his question, like obviously needs a thorough reality check with the real grass and real soil because well, the real grass and real soil would naturally increase the scoring damage to the root system and several failure mechanism to the grass canopy and and the soil. So obviously it's really challenging, but it's closer to the reality. And so in the future, my supervisors and I would definitely consider to do, if we have the opportunity to do more like field work, if that's possible, like and if that's not possible, like we do have a very large scale like experiment facility in the water research.
Oh, that's great.
Yeah, like so we can potentially basically put the real grass and turf into the film that I'm currently using. I have seen the previous scholars do this kind of study before in Europe, and I think it's also a feasible approach to tackle this problem.
Yeah, I think sometimes you don't also need to basically repeat your experiments in the field, in the flume. Sometimes you just need to go in the field and make some measurements that reassure you that what you are actually doing in the flume makes sense. So it doesn't have to that you have to repeat the same experiment. So I think if you have the chance, that would be valuable. But from what you say, you have a very good setup, experimental setup. So I think I'm pretty sure you will get very good outcomes from it. So, and you seem to be in the right department, in the right environment. So that's awesome.
Okay, thank you very much.
Yeah. Okay. Well, thanks all. I just thought it was great to still have a bit of a chat with everyone. It feels like we run out of time to ask everyone and to get a bit of feedback both ways. So thank you very much again, everyone. And see you around. Well, you know where we are, you know our faces now. So look forward to stumble into you in the future. So all the best for your studies and see you around.
See you.
Bye.
Bye. Thank you very much.